Hello everybody. Are you guys there? Yes, good morning, good morning. Yeah. Am I audible, visible, everything is perfect? Yes or no? Hi Manju, how are you? Preparations எல்லாம் எப்படி போகுது? All good. And you guys have to like the video right now itself. Okay. And in the one we are going to discuss nuclei as well as semiconductor. So இப்போ வந்து உங்களுக்கே தெரியும் இந்த nuclei chapter வந்து it is a very small chapter. So அதனால fast we can finish and we can straightly go for semiconductors. ஏனா semiconductor வந்து it's something like in the horror movie மாதிரி for few students. So yes, I'm good. Yes, good morning. Okay. So எல்லாருமே ஹாப்பியா சேஃபா இருக்கீங்களா? Everybody, and you guys are ready for the session? Hi. I'm waiting for you people. Yes, perfect. So இப்போ வந்து உங்களுக்கு இந்த video வந்து you can share with your friends. Okay, so we need more people to come, and finally we have reached 30k. Okay, and that was a huge your appreciation for us. So adanala vandu I have to say we have to say thank you so much. Idu vandu I mean in a short time 30k ingradha avlo easy alla, and you people made it. Thank you so much. Hi sweet candies. Yes, I'm happy, I'm safe, and I'm very much fine. Hi, thank you Tarun. Yes, so இப்போ வந்து we are going to start the session. So idhula வந்து first we are going to start with the what is our first chapter, nuclei. ஏனா வந்து last class we couldn't finish that chapter, so இப்போ வந்து we are going to finish. idhula வந்து we will be solving some questions, and also let me tell you in the Sunday in the chapters order. Okay, in the dual nature, atom, nuclei, semiconductor, in the 4 chapters order combination we are going to do a lot of questions. Okay, so adukapram you can make sure in the modern physics வந்து it is going to be the easiest, and you will be getting the full marks. Whatever be the questions asked in that, you will be able to solve the question. And also you guys know in the Neet exam we can see that adoda standard வந்து கொஞ்சம் last year question paper பாக்கும்போது we can understand adoda standard வந்து increase ஆச்சு. Correct இல்லையா? So அதனால we need to prepare ourselves to the next level. So adakaga we will do easy questions, we will do tricky questions but easy, we will do tricky questions but hard. Okay, and also we will do some difficult level questions also. Yena vanta we need to improve our level. Okay, ipo vanda inta level a irukke, ana vanda inta level ku ponam. Modern physics la adu vanda easy da. Okay, so to become pro in modern physics வந்து easy தான். So அதனால தான் I'm telling you Sunday sharp 10 o'clock you guys have to attend the session. அந்த அளவுக்கு important தான் அந்த session. புரிஞ்சுதாடா everybody? Yes or no? So how many of you will be joining that session? Please let me know in the chat box. Everybody, how many of you will be joining on Sunday session 10 o'clock? Sharp 10 o'clock everyone should be there. Okay va? Yes, tell me. Yes, so இப்போ வந்து we are going for the session nuclei da. Okay, something was happened it seems. Okay, fine. Yeah, fine, let's see. So இப்போ வந்து yes I want that spirit, I want to see all people on that day. So இப்போ வந்து we are going for the chapter that is nothing but nuclei. Okay, so in the chapter first thing is we should understand few things about this nuclei. Correct? So in the nuclei na adula வந்து nucleons irukkum. Correct? idhula வந்து nucleons irukkum. So now tell me in the nucleons na enna? In the nucleons na enna? Something was happened, right? Little dim. Okay, so now tell me nucleons na enna? It is nothing but the neutrons plus protons. Correcta? So in the neutrons plus protons together we will be calling it as nucleons. In the nucleus, in the nucleus, we are talking about nucleus, right? In the nucleus, in the protons and neutrons together, okay? And in the neutrons, okay, neutrons kandupidichadhu yarada? In the neutrons, protons vandu last class we have discussed about it. Adu vandu Rutherford da. Now you guys have to tell me, in the neutrons kandupidichadhu yaru? Who found this one? Nothing but our James Chadwick, right? So, இப்போ வந்து protons na அது வந்து Rutherford and neutrons na வந்து Chadwick da. Okay? So, you should know about this as well. Next வந்து, you should understand one more thing. In the nucleons na we said protons and neutrons. இதோட mass வந்து approximately same. Okay, va? In the mass of protons and mass of neutrons, it is approximately same. Very good, super Manju. Okay, and adoda value vandu, okay, adoda value vandu 1.67 into 10 to the power minus 27 kg. This is the basic we should know about the what our nucleus. Purinjidada. So first part is over. Idhula vandu whatever I have mentioned, you have to study. And adukappuram in the neutrons and protons we have mentioned, right? So idu vandu we have mentioned idu vandu together in the nucleus kulla idellame vandu together it is sitting together. அப்படினா அதுல வந்து அதுக்கு ஒரு ரீசன் இருக்கணும்ல. If you guys are just coming together and studying, which means அந்த டைம்ல எக்ஸாம் இருக்கு, கரெக்ட்டா? இல்லனா you people will play. Am I right or wrong? Correct அல்ல? So இப்போ வந்து எக்ஸாம் இருந்துருச்சுனா you people will come together and you will study. So அந்த மாதிரி ஒரு ரீசன், ஒரு சாலிடா ரீசன் இருக்கணும். So இதுல வந்து இந்த நியூட்ரான் புரோட்டான், நியூட்ரான் நியூட்ரான், proton proton. So in the combination there is a force involved. Adada vandu whatever we are calling it as the nuclear force. Okay, in the nuclear force nallada in the protons neutrons ellame together in the nucleus kulla it is in the nucleus. The only reason is nothing but the nuclear force. So nuclear force patti we will study again. So in the nuclear force irukku, and also in the protons na usually we will say adukku vandu positive, right? And neutrons na we can say that neutrons are neutral. Okay, in the neutrons na adu vandu neutral da. Purinjidada everybody? Understood na? Give me a thumbs up. So this is the basic idea about the nuclei chapter. So first one we should know in the nucleus protons and neutrons together adu together we will call it as nucleons. Idhula vandu we know protons found by Rutherford and neutrons by Chadwick, and mass of proton and neutron also you guys should know. Adu approximately 1.67 into 10 to the power minus 27 kg da, and in the neutrons oda charge neutral da. Purinjidada? Everybody understood? Yes or no? Give me a thumbs up everybody. Yes, perfect. So appadina we should know if I am representing an atom. Okay, if I am representing an atom, I can represent like this. Okay, A na ennada? A. What is the meaning of A? What it is representing? In the A na enna? It is nothing but the mass number. Okay, so can you just tell me what is mass number? Z na atomic number. Purinjidada? So right now A na mass number as well as, very good, Z na atomic number. So atomic number, which means from this you will be getting the number of protons. Also that is equal to number of electrons. Yena or atom it is electrically neutral da. Appadina we will get to know adile irukra protons oda number and electrons oda number same da. Number of protons which is equal to number of electrons. Appadina we can say that here we have the atomic number that is representing the number of protons, and it is also equal to number of electrons as well. Now my question is, what does this mass number represents? Mass number na enna? It is nothing but, together you can say, number of nucleons. Okay, so in the mass number is representing, இப்போ வந்து classல let us say we have boys and girls. Okay, so together we will say the students. Correct? So அந்த மாதிரி இந்த what is in the nucleus குள்ள இருக்கிற nucleons ஓட number தான் what is the whatever we are calling it as the what is the mass number. அப்படினா இப்போ வந்து I just wanted to I know what is A, I know what is Z. Now my question is, how I will find the number of neutrons? புரிஞ்சுதா? So இப்போ வந்து I wanted to know, I know atomic number, I know mass number. Now you guys have to tell me in the number of neutrons என்ன? Number of neutrons from atomic number and mass number. How I will be finding the number of neutrons? Can you give me an equation for this, everybody? Can you give me an equation for it? இப்போ வந்து number of neutrons that we need to find. இப்போ வந்து we know number of nucleons. Number of nucleons na enna? Number of nucleons na enna? Number of proton plus number of neutrons. அப்படினா I know that A na number of proton plus number of neutrons da. Number of protons we already said, adukku vandu we can also, very good. So we can also represent it as the atomic number plus N. அப்படினா number of neutrons வந்து mass number minus atomic number. புரிஞ்சுதாடா everybody? If you understood, give me a small fire in the chat box, everybody. So we have discussed about the atomic number as well as mass number. In the மாதிரி தான் we will represent an atom. அதில் A na mass number da, Z na atomic number da. In the Z value if it is given, you should understand அது வந்து equal to number of protons. இல்லனா you can say number of electrons. Okay, next one in the A value representing that number of total nucleons. Okay, nucleons we already know. Nucleons na ennada? It is nothing but the protons plus neutrons. In the nucleus kulla irukra what is a components oda total number da in the nucleon, or together we will say it as nucleons. Okay, adoda number da in the mass number. அப்படினா if you need to get number of neutrons na, you should go for A minus Z. Everybody understood? Yes or no? Yes or no? Next one we should know the size of the nucleus. So size of the nucleus usually we will represent in terms of the radius. Okay, இப்போ வந்து இந்த radius இவ்வளோதான்னு சொல்லிட்டேன்னா you will be get to know. Okay, இதோட what to say? Very good. Thank you so much, guys. Okay, so இப்போ வந்து மறக்காம like பண்ணிக்க, also share with your friends. மறக்காம share with your friends. Oh my God, don't watch that. That was happened in Corona time. Don't even watch. I'm trying to delete it. Okay. So now we are just going for the next one, that is about the radius. So in the radius na, okay, in the radius R na, what is it is representing? It is actually proportional to 1/3, or let's say we can say 8 to the power 1/3. Okay, 8 to the power 1/3. So in the proportionality change பண்றதுக்கு we should use a constant. அதுதான் வந்து I'm representing it as R0. Okay, so I can say R0 all to the power 1/3. Sorry, R0 8 to the power 1/3. அப்படினா இந்த R0 ஓட வேல்யூ புரியணும்ல. So அதுதான் வந்து 1.1 into 10 to the power minus 15 meter. Okay, calculation பண்ணும்போது especially when it comes to Neet na, we need to get a close value. So அதனால இந்த 1.1 எல்லாம் தேவையில்ல. You can just straightly multiply it with 10 to the power minus 15. That is enough. Okay, so you just need to check the options. இந்த options வந்து close values இல்ல வந்து கொஞ்சம் difference இருக்கா, அவ்வளோதான். Or I mean whenever you are doing any calculation, ஏன்னா many students வந்து physicsல calculationக்காக they are taking a lot of time. Okay, அதுக்காக தான் I'm telling you, now when you're practicing, இப்போ வந்து you guys have to do with this thing only. ஏன்னா calculation speed increase ஆகிறதுக்கு ஒரே ஒரு solution தான் இருக்கு, maximum number of questions you have to do. Okay, அதனால அதில் compromise இல்லை. ஆனால் எக்ஸாம்பிள் you can just check the options, accordingly you can just take the values. Okay வாடா, so இதுதான் வந்து we should study in the R naught ஓட value as well as in the relation கூட we should know. Next வந்து இந்த nuclear density தான். Okay, nuclear density. So இப்போ வந்து இந்த nuclear density, when I'm talking about nuclear density na, அதோட value is independent of mass number. I'm telling you, you just note this. ஏன்னா இந்த point வந்து neat point of view ல very very important. Note பண்ணிக்கோடா. Okay, very yes. This is board exam in positive in and only because of you. Thank you so much Rohit, thank you so much. Okay, so nuclear density aila vandu important ana point enna, it is independent of the mass number. Note panniko, இந்த point வந்து அவ்ளோ important தான். Okay, in the nuclear physics la, in the nuclear chapter la irundha varapora questions வந்து we have a clarity. Okay, அதனால தான் few points I'm highlighting you, அது வந்து focus பண்ணிக்கோ. கரெக்டாடா? So இதில் வந்து independent of mass number, அதுதான் வந்து first thing. And why it is so? அது வந்து almost it is going to be a constant value. In the nuclear density வந்து it is almost a constant value. Okay, so nuclear density na enna? Nuclear density na enna? Mass by volume. கரெக்டா? Nuclear density na அதோட equation வந்து mass by volume. So இப்போ வந்து you should tell me in the nucleus ஓட mass how we will find it. In the nucleus ஓட mass வந்து how we will be finding it. அதுக்காக can I just tell you அதில் இருக்கிற nucleons ஓட number வந்து A. கரெக்டா? clear-ஆ புரிஞ்சுக்கோ. இப்போ வந்து what I'm saying in the nuclear density na அதோட equation வந்து mass by volume தான். Correcta? So இப்போ வந்து I wanted to know mass of the nucleus. Mass of the nucleus na I can go for the mass number. Mass number na it is nothing but the number of nucleons. Correcta da? Number of nucleons. அப்படினா I can just say that in the number of nucleons into the mass of nucleons. Nucleons la we have mentioned இதோட mass வந்து approximately same. அப்படினா I'm just using AMP. இது வந்து approximate value da, we will get to know this is having some difference and all. Let it be there, we can just discuss it later. Now you have to focus in the mass by volume. இதுல வந்து mass na very simple, in the mass number into mass of the nucleons. Okay, mass of the anyone. Okay, either you can go for protons or neutrons. ஏன்னா அதோட mass வந்து approximately same. So, I mean, there is a small variation that is not even considered. So, adanala I got this. Now, 4 by 3 pi r cube. Now, when we are talking about r cube, r க்கு வந்து we already know this equation, correct? So, A into mass of proton or mass of neutron, anything is fine, divided by 4 by 3 pi into r naught a to the power 1 by 3 all cube. Yena I have replaced r. So when I am saying this thing, please note it down. Yena later வந்து why in the nuclear density constant ஆ இருக்கு, அந்த மாதிரி confusions இருக்கும். அதனால தான் I'm telling you, please not everything. So இதில் வந்து பார்க்கும்போது a to the power 1 by 3 all cube na அது வந்து a to the power 1. அப்படினா இந்த values வந்து cancel ஆக போற, and finally we will be having the mass of the nucleon divided by, or let's say mass of proton 4 by 3 pi r naught cube. So together if you are just looking onto this equation, mass of proton அது வந்து constant da, 4 by 3 pi constant da, r naught constant da. அப்படினா இதோட value வந்து it is going to be constant. புரிஞ்சுதாடா? Everybody understood? Understood na? Give me a small fire in the chat box, everybody, please. Everybody, if you have understood, really Rohit, So everybody, please wish him happy birthday, Rohit. Happy birthday. So now we know that in the nucleoda size we will represent in terms of R, and the value R naught 8 to the power 1 by 3. R naught oda value 1 dependent of mass number, and it is almost constant. Why it is constant we have already derived here. Okay, and idoda value it is coming as 3.2727, sorry, 3 into 10 to the power 17 kg per meter cube da. In the value kuda you can just study. Okay, so idhula you will be getting 3 into 10 to the power 17 kg per meter cube da idoda final value. Everybody has written on the note ready. I mean, have you written it? Yes or no? Yes or no? Everybody has written everything on the notebook. Yes or no? Tell me da. Hi, good morning, good morning, good morning. Yes. So now the thing is like in the topic syllabus illa. Okay, in the year in the syllabus illa. Yeah, I mean, even if it is not in the syllabus also, few students will insist like we need to study. Those who want it, you can just go through it. I'm not going to waste my time. So you can just go through it. Okay. Next one, we should know what is 1 AMU. Okay. What is the value of 1 AMU? So that value it is given 1 by 12th of the mass of one of the carbon 12 atom at rest and in the ground state. Adoda value it was almost equal to, in the 1 AMU value it is almost equal to what? Equal to what? 1 AMU is almost equal to our mass of proton or mass of neutron. In the value we have seen this before, right? 1.66 into 10 to the power minus 27. Okay, and the value we have already seen before. What we have studied in that? Mass of proton, and it is approximately equal to mass of neutron. Adada 1 AMU. Now the thing is like, you should know the energy equivalent. Okay, the energy equivalent for 1 AMU. In the value kuda you can study 931.5 mega electron volt. So not this value also, yena idu kuda important da, the energy equivalent to 1 AMU. 1 AMU na adoda value it is already written there, 1.66 into 10 to the power minus 27. So 1 AMU oda value, mass of proton, mass of neutron same da. Next in the 1 AMU, it is a mass, right? And the mass convert in the form of energy. We are going to study that. And the time adukku equivalent and the 1 AMU mass equivalent energy da 931.5 mega electron volt. Purinjidada everybody? Then give me a small fire again in the chat box, those who understood. If I need to repeat, please let me know. Okay, so now my question is, how many questions you are doing? I mean, if you are preparing for any chapters, how many questions you are practicing every day for physics specifically? How many questions you are practicing? Also, I wanted to know that, I wanted to tell you, those who have not attended the live session which happened on 2 days back, Sunday 10 AM onwards. Okay, we are not restricting the time. The time till you people become bored. Okay, and the time varakum we are going to solve the problems. Okay, in the one day chemistry and physics will come together and we are going to rock on that day. We will solve many questions and I want your participation. Okay, questions practice பண்றது if you are sitting alone na அது quite boring இருக்கும். So when it comes to a platform like this, you will have many students to compete. So you will feel like, yeah, I want to give the answer first. Okay, I wanted to do this. So அந்த அளவுக்கு you will feel that what to say, and the competitive mind இருக்கும். So அதனால தான் I'm telling you, Sunday sharp at 10 o'clock you can join the session. Correct? Okay, so how many of you are studying in 12th right now? Okay, for everybody this board exam is there. Oh my god. no issues da, but at least do some minimum questions. ஏனா வந்து இந்த மார்ச்சுக்கு அப்புறம் only hardly 1 month தான் இருக்கு. அதுல வந்து you know how many chapters of physics, chemistry, bio is there, and your major focus is going to be bio, I know. ஏனா அதுக்கு தான் what is a high weightage, okay, and easily you can crack it. So you people will give more focus on biology and then chemistry, and the third priority da in the physics ku. So adanal I want you people to make sure some questions, okay, I mean if you can do a minimum of 20-25 questions nalum paravaillada, but try to do it, spend some time for it. Okay, ipo vandu nuclear physics we are going to finish, adukapram we are going for semiconductors. So idukapram you can just do some 25 questions. Okay, if you need more questions now, you just let me know in the comment box. I will share some questions also. If you are struggling with ma'am, I'm not getting the questions up there, you can just let me know in the comment box. Okay, Vada? So now we are just going for the next important topic. That one nothing but our binding energy. Okay. No. Nuclear force da. We have said we will discuss this nuclear force later. So in the nuclear force na, as I mentioned, okay, if this neutrons, protons ellame together, if they need to be together, okay, if they need to be together, then definitely வந்து அதுக்கு ஏதாச்சும் force இருக்கணும். அந்த force தான் இந்த nuclear force. Okay, இதுக்கு வந்து பாசிட்டிவ் நெகட்டிவ் நியூட்ரல் அந்த மாதிரி எது செப்பரேஷன் எதுவும் இல்லை. இப்போ வந்து it will be always attractive. இந்த ஃபோர்ஸ் வந்து ஆல்வேஸ் வந்து அட்ராக்டிவாக இருக்கும். And this will be in between proton, this will be in between proton, neutron. Also it will be with the neutron as well. ஆனால் இதோட ப்ராப்ளம் என்னன்னா, இது வந்து ஸ்ட்ராங் ஃபோர்ஸ் தான். ஓகே, இந்த நியூக்ளியர் ஃபோர்ஸ் வந்து இட் இஸ் த ஸ்ட்ராங்கஸ்ட் ஃபோர்ஸ். ஓகே, இட் இஸ் வெரி வெரி ஸ்ட்ராங். ஓகே, த ஸ்ட்ராங்கஸ்ட் ஃபோர்ஸ் இந்த ஃபண்டமெண்டல் ஃபோர்ஸ் தான் இந்த நியூக்ளியர் ஃபோர்ஸ். ஆனால் இது வந்து ஷார்ட் ரேஞ்ச் தான். Okay, short range na, it will be approximately 10 to the power minus 15 meter da adoda. I mean in the nuclear force vandu apply pandradhukku it will be approximately 10 to the power minus 15 varaikku da it is possible. புரிஞ்சுதா? So அதனால nuclear force வந்து short range da. Next வந்து இது வந்து strong force da, and also இதுக்கு வந்து there is no such polarity issues, neutron proton neutron இந்த combinationsல இந்த nuclear force வந்து it will work. Okay, so nuclear force is charge independent, that's what I have mentioned, and it is always going to be attractive, and it is spin dependent. Okay, in the nuclear force வந்து it is depending upon the spin only, and also this is a non-central force. So nuclear force vandu you should know some basic ideas, adha vandu we have discussed right now. Okay, so nuclear force oda properties na you don't need to even revise. First vandu 8th standard la we have started about this fundamental force. Adula vandu we were just discussing idula vandu strong ana force vandu nuclear force. So first vandu strong da. So right now we have mentioned something about something strong, right? Now go for the weak part. Weak part na enna, idu vandu short range da. Hi, good morning. Okay, short range da, and adoda range vandu 10 to the power approximate vandu adoda influence irukra zone vandu 10 to the power minus 15 meter da, or else 1 femtometer da idoda range. Okay, and also idu vandu always attractive ah irukum. Okay, it is always attractive, and also it is charge independent. இது வந்து proton proton neutron எல்லாத்துலமே இருக்கும். Okay, and what else we have studied? It is a non-central force. Okay, so அந்த மாதிரி few important, it is spin dependent. So these are the points you should remember. இப்போ வந்து important ஆன next topic க்கு தான் we are going for it. அது வந்து nothing but binding. வந்து we put some 1 kg sugar and 1 kg salt together. So total we have to get 2 kg, right? Correct? So I have checked the weight of this sugar, adu vandu 1 kg da, salt vandu 1 kg da, and when we are keeping it together total vandu 2 kg irukkum. So ipo vandu adula vandu shortage irukku. Okay, ipo vandu adula shortage irukku. So adula vandu what we should understand, somewhere this was lost. Correct? So அந்த மாதிரி as you know in the nucleus la, okay, nucleus la இருக்கிறது வந்து இந்த nucleons தான். கரெக்டா? இந்த nucleus இல்ல nucleons இருக்கும். இந்த nucleons na what is that nucleons? Can you just tell me in the chat box? Nucleons na it is nothing but our protons and neutrons. புரிஞ்சுதா? nucleus na adila protons and neutrons இருக்கும். So in the protons and neutrons na, okay, protons and neutrons. இப்போ வந்து I'm going to calculate. இதுல வந்து mp, இதுல வந்து mn. So இதோட நம்பர் வந்து z தான். Okay, number of protons கிறது it is nothing but the total mass of protons. Okay, total mass of protons கிறது it is nothing but number of protons into mass of proton. அப்படினா now you guys have to tell me what is the total mass of neutrons. Can you just tell me what is the total mass of neutrons? Total mass of protons வந்து you have found it. Okay, so இப்போ வந்து I'm going to find the total mass of protons. Okay, so அதுக்கு வந்து we have one equation, number of protons into mass of proton. Correct, mass of proton. Adha what we have mentioned, z into mp. இப்போ வந்து I wanted to know the total mass of neutrons. So how we will be finding it? So number of protons ku badala we will be writing number of neutrons. Okay, into next one the mass of proton instead of we will write mass of neutrons. இப்போ வந்து you should tell me what is this mass of neutrons? Sorry, number of neutrons. What is this number of neutrons? Can you give me because we have already found it. Now tell me what is mass of protons? What is mass of protons? Sorry, what is number of neutrons? அது வந்து a minus z da. Correct? We already written this. A minus z da number of neutrons into mass of neutrons. Correct? Yes or no? Tell me everybody. If you understood, give me a fire in the chat box. The total mass. Very good, Manju. Very good. So, if you understood, give me a fire in the chat box. Total mass of protons and total mass of neutrons. Adakaga, the number of particle into mass of that particle. அப்படினா number of particle வந்து for protons க்கு z தான், neutrons க்கு வந்து a minus z தான். அப்படினா we can say that the total mass, okay, total mass of nucleons, na it is nothing but zmp plus a minus mn. Am I right or wrong? Tell me, am I right or wrong? Very good. Hi Hebsi, you back again. Okay, so இப்போ வந்து we got the total mass of the nucleons. Okay, nucleons. இப்போ வந்து இந்த nucleons combine பண்ணிட்டேனா அதோட total mass வந்து I have to get this one. ஆனா listen here. இப்போ வந்து what we have said, in the nucleusல இந்த nucleons இருக்கு. Okay, so now total mass of nucleons should be equal to mass of nucleus. Correct? Okay, the total mass of the nucleons, the particles inside, okay, should be equal to mass of the whole nucleus. ஆனா இது வந்து equal அல்ல. Okay, this is not equal. So now here comes the Einstein's mass energy relation. In the mass can be converted as energy. Okay, in the mass can be converted as energy. So whatever I'm writing on the board, please note it down. Yena few days kapra you can't even remember each of these things. So on the time la detailed arikra note thevaiya irukku. Adinala I'm telling you, please write everything whatever I'm writing on the board. Okay, so total mass of the nucleons வந்து அது வந்து total mass of nucleus. Okay, equal alla. So which means Einstein's mass relation is having some importance over here. Adudha vandu whatever I have mentioned, mass can be converted as the energy. So idhil irukra change na enna, total mass of the nucleons. Total mass of the nucleons na enna da? We have already mentioned ZMP plus A minus ZMN minus mass of the nucleus. Okay, so adudha vandu I am writing it as capital M, mass of the nucleus. Idudha vandu I am calling it as delta M in the mass defect. So now tell me guys, what is mass defect? Mass defect na enna? It is nothing but the difference between, okay, difference between what? The total mass of the nucleus and the total mass of the nucleons. Okay, இப்போ வந்து if you are just taking few balls in a packet, okay, so அந்த balls ஓட mass வந்து calculate பண்ணும்போது இதோட total mass match பண்ணணும். ஆனா இந்த கேஸ்ல அப்படி எதுவும் nothing is happened. Check பண்ணும்போது இந்த nucleus ஓட value வந்து கம்மி தான் comparing with the mass of the nucleons. இந்த total mass of protons, இந்த total mass of neutrons ஓட value வந்து calculate பண்ணும்போது it is more than the mass of the nucleus. So அதிலிருந்து we have understood one thing. அந்த understanding என்னடா? அந்த understanding தான் mass is converted as energy. Okay, so இதில் இருக்கிற அந்த change, இந்த defect, அந்த mass இல் இருக்கிற அந்த difference, இந்த delta M வந்து, இந்த delta M is converted as energy, and the energy is utilized for, okay, and the energy is utilized for keeping all these people together. Okay, இப்போ வந்து உங்களுக்கு வந்து ஒரு friendship maintain பண்ணணும், அதுக்காக நீங்க வந்து கொஞ்சம் effort எடுக்கணும்ல, கரெக்ட்டா? Yes or no? Okay, I'm waiting for you people only. You people are not coming on time. You people are not coming on what is a correct date. I don't know what you guys are doing. Okay, so இப்போ வந்து what I said, so இதுல இருக்கிற இந்த mass defect வந்து utilized as energy. அந்த energy எதுக்காக utilize பண்ணிருக்கு? To keep all the proton neutron together. Okay, to keep everyone together, this mass has converted. Okay, so right now idila vandu we can say in the delta M vandu it is completely converted as energy. Okay, it is completely converted as the energy. The energy equivalent, okay, the energy equivalent, I could say that in the energy vandu according to Einstein's relation, in the delta M the defect ஆச்சு, இல்லனா missing ஆகிற mass into c square. Correcta? So அப்படினா I can say in the energy, in the binding energy வந்து to keep all the electrons, to keep the all neutrons and protons together. Otherwise I could again say one more thing. பரவாயில்லடா, focus on question practice, no issues. Okay, இப்போ வந்து உங்களுக்கு concept clarity இருந்துருச்சுன்னா இந்த sessions attend பண்றது it is not required. Okay, ஆனா வந்து Sunday session you have to attend, ஏன்னா அதுல வந்து many questions, different types of questions வந்து we are going to discuss. Okay, so இப்போ வந்து again back to our binding energy. Okay, those who are coming new, இப்போ வந்து உங்களுக்கு வந்து இந்த சேனலை subscribe பண்ணலாம், ஏன்னா we are going to do a lot of things for you. Okay, இப்போ வந்து March 14 தான், இன்னும் few days இருக்கு, இந்த few daysல amazing ஆன sessions வந்து waiting for you. So அதனால இப்பவே channel subscribe பண்ணிக்கோ. Also இந்த நம்பிக்கை batch இருக்கு, நம்பிக்கை batchல it is going to start on March 16th. So இப்பவே join பண்ணிக்கோ. Details ஏதாச்சும் வேணும்னா you can just check it in the description box. Yes, I'm waiting, Deepak. Waiting for that session. Okay, Hebzi, I will also wait for you. Last time you cheated me, correct? Okay, you just attended the first part, then you just went somewhere. Then you came for chemistry. Okay, so இப்போ வந்து we understood E na delta M C square தான். கரெக்டாடா? Yes or no? Yes or no? So இதில் வந்து delta M அது வந்து mass defect. Mass defect na என்ன? Mass defect na என்ன? Yes, it is nothing but the total mass of the nucleons. Okay, the total mass of nucleons. அப்படினா அது வந்து ZMP plus A minus ZMN minus mass of nucleus into C square. Okay vada? So இதுதான் வந்து நம்ம energy equation. So in the binding energy வந்து I can say in two different perspective. Okay, just understand. இப்போ வந்து I can say in the neutrons, protons எல்லாத்தையுமே I have to keep it together. So the energy required for that. அதுதான் வந்து binding energy. Okay, illana I can say that the minimum energy required to disassemble, okay, to keep this neutron proton away, அதுதான் வந்து இந்த binding energy. ரெண்டோட மீனிங் வந்து சேம் தான். கரெக்ட் இல்லையா? ஓகே, ஃபர்ஸ்ட் வந்து the energy required to keep it together. Second வந்து the energy required to take anything from here. Means, I mean, meaning same da. So அதுதான் வந்து binding energy. அந்த binding energy கிடைக்கிறது, அந்த binding energy ஓட reason, அந்த source என்ன, அந்த binding energy ஓட source என்ன, give me the answer in the chat. Everybody, அந்த binding energy ஓட source என்ன, binding energy ஓட source என்ன, tell me. Everybody. So the binding energy order, hey, why you people are not even saying anything? Okay, and the binding energy order reason na idhula irukra mass defect da. So adinala da and the binding energy kaga I have put it as delta M C square. Okay vada, adukku da I have put it as delta M C square. So now in the energy vanda delta M C square, delta M in the mass defect na very simple, total mass of the nucleons minus total, or let's say the mass of nucleus into C square da idoda binding energy. And the binding energy vanda I can define it like this: the minimum energy required to break the nucleus da nothing but the binding energy. Okay, or otherwise we can say that the amount of energy released during the formation of a nucleus. Okay, that is also, you can just write it in your own way, no issues, but you should get the understanding. Now let us say, my question is, okay, you guys have to tell me the answer. Okay, my question is, if delta M is 1 AMU, can you give me the binding energy equation? Now you can just give me the answer. என் ஸ்டேட் வந்து நான் வந்து எல்லா ஸ்டேட்ல இருக்கடா. So tell me, indula vandu if the delta M is 1 AMU na, in the binding energy, what is going to be the binding energy? What is going to be that? What is going to be that? Idu vandu we know delta M C square da. Correcta? So adinala in the delta M, okay, adukku equivalent ana, okay, we have mentioned about if this delta M, or let's say if the mass is 1 AMU na, adukku equivalent a irukra energy, okay, adukku equivalent a irukra energy vandu we have already discussed about this. So that is nothing but 931.5 mega electron volt. So idukku da I have told you to write. Okay, so ipo vandu in the delta M 1 na, okay, in the delta M vandu 1 AMU na, adoda value vandu it is going to be like this. Ipo vandu in the mass defect it is given in AMU na, you can just do one thing, multiply this with the value. Ipo vandu I am giving you in the mass defect vandu 5 AMU. Appadina you can just write 5 into 931.5 mega electron volt. Purinjadada everybody. So the thing is like very simple. E is equal to delta M C square. Ipo vandu in the delta M, ஓகே இந்த மாஸ் டிஃபெக்ட் வந்து 1 AMU னா அதோட வேல்யூ வந்து 931.5 மெகா எலக்ட்ரான் வோல்ட் தான் அதோட வேல்யூ. இப்போ வந்து I'm just slightly changing. இந்த delta M is given in terms of AMU. The question la in the delta M வந்து given as 5 AMU na you can go for 5 into 931.5 electron mega electron volt. Don't forget about mega electron volt. adula 10 to the power 6 multiply பண்ணனும். So don't forget about it. Purinjada everybody? If you understood na give me a fire, and those who have joined now you can just like the session, also share with your friends, and don't forget about Nambikai batch. Yes, give me a fire, a small fire you can give if you understood this part. Binding energy. Idha in the chapter oda base part. Binding energy na it is due to the mass defect. Okay, when the nucleons combine to form a nucleus, adula irukra release pandra energy da ida binding energy, or you can say the energy, the minimum energy required to break the nucleus, adha vandu namma binding energy. ipo vandu inda delta M garada 1 AMU na inda energy oda equation vandu 931.5 mega electron volt. Very good, very good, very good. Okay, so next one the binding energy per nucleon. Okay, binding energy per nucleon, which means when we are finding binding energy divided by the mass number, we will be getting the binding energy per nucleon. Okay, so idhula vandu what is the importance of this value? So idha vandu decide panna poren. Okay, in the nucleus oda stability vandu decided by in the binding energy per nucleon. So in the value vandu in the binding energy per nucleon vandu high na I can say it is more stable. Okay, stability wise idu vandu great ah irukku. புரிஞ்சுதாடா? Everybody understood? Binding energy per nucleon increased, or let's say that is very high na அதோட meaning அந்த nucleus oda stability வந்து high தான். Which means இப்போ வந்து we have a group of friends. Okay, someone is coming and saying some nonsense, and immediately அந்த friends group வந்து destroy ஆச்சு. Which means stable அல்ல. Okay, so அந்த friendship strong தான். Okay, each and every person know each other. அப்படினா binding energy per nucleon வந்து high ஆ இருக்கு. So if somebody comes nalum, if someone was doing something nalum, in the friendship vandu proper stable ah irukum. So adha vandu idoda hi Siva. Okay, yeah, so adha vandu idoda concept. Next vandu we have a graph. So on the graph il irundha we have to understand which one is having the in the iron ku da in the binding energy per nucleon vandu high ah irukku. Yeah, so in the graph da very important. Okay, so idhula vandu paakumbodhu you can see in the region la irukra, okay, in the region la irukra particles ku vandu energy, binding energy per nucleon vandu high ah irukku, which means avanga vandu stable ah irukku. And whenever we are just checking on this side as well as this side, adoda stability vandu kammi da. Okay, so idhula vandu that is what I said, binding energy per nucleon vandu less value na stability vandu less da. Adoda value high na we can say adukku da vandu stability more. So in the graph paakumbodhu you can just see that in the iron ku da what is happening, binding energy, that is what the most stable one. Okay, that is the most stable one. Okay, yes. So now you can just see that whichever is coming over here, okay, which one is having less mass number, adula vandu paakumbodhu what is happening, idu vandu fuse aga pore. Okay, இப்போ வந்து சிங்கிளா இருக்கும்போது ஸ்டேபிளா இல்ல அப்படினா I'll call my friends and I will come to a very high stable state. புரிஞ்சுதா? So இப்போ வந்து atom mass number வந்து கம்மியா இருந்தா what we will do, we will keep people together and we will come to the stable state. அதுதான் வந்து whatever we are calling it as nuclear fusion, fusing together. Okay, we are fusing together. So அப்படினா இந்த mass number கம்மியா இருக்கிற elements வந்து they will combine, they will fuse together and they will go for nuclear fusion and they will come to the stable state. இப்போ வந்து இந்த uranium and everything, if you are just looking on, what will happen? அதுக்கு வந்து இந்த mass number high தான். Okay, they need to split and they need to come to a stable state. So அதுக்காக what we will do, what these elements will do, they will split and they will come to stable state. Okay vada, they will come to stable state. அதனால we can say that இதில் இந்த mass number high னா what is happening அது வந்து split ஆக போற and it will come to the stable state. அந்த process தான் what we are calling it as the nuclear fission. Okay, so in the graph பார்க்கும்போது you can just see that which are the elements is going for fusion and which are the elements is going for fission. So in the graph வந்து important. So இதில வந்து if you are just checking on it, இதில maximum வருது. Okay, one second. Okay. Okay, so இதில வந்து maximum வர போறது இந்த what is our iron da, adikappuram da what is happening, the rest of the particles, and here splitting and fusion will happen. Fusion will happen for the particle which is having less mass number, and fission will happen for the mass number. If the mass number is high, they will go for the no on the half-life radioactivity, nothing is there. Don't even look at that, please. It is a request. Okay, that is not in the syllabus. இப்போ வந்து you have studied everything. Okay, அதுக்கப்புறம் எனக்கு வந்து கொஞ்சம் extra I want to learn na, அந்த momentல you study radioactivity and all. Okay, so in the nuclear fission and fusion that we are going to discuss right now. So in the fission la we know that அதுல வந்து heavy nucleus வந்து split ஆக போற. Okay, and also fusion now is that lighter nuclei, which means which is having less mass number, அவங்க வந்து combined they will become a element which is at stable state. Okay, next வந்து இதில் இருக்கிற energy release, இந்த process இதில் இருக்கிற energy release na, it was coming around 200 mega electron volt. ஆனா when I am talking about fusion, அதில் இருக்கிற energy வந்து very high. புரிஞ்சுதா? So when I am talking about fusion, அதில் இருக்கிற energy வந்து very high. Next வந்து we will be for fission now we said it will be used for the in the fission process in the fission process what is actually happening, the mass number, high mass number nucleus da coming, splitting and coming to it. So adanala adukku example da what is given over there. And idhula nuclear fusion ku example na fusion la varudhu in the deuterium, tritium appadi irukra small elements da. Next வந்து இது வந்து initiated by neutrons. The bombarding with neutrons will leads to the nuclear fission. And nuclear fusion la வந்து it is a very high and temperature வந்து அவ்ளோ ஹையா இருக்கும். Okay, temperature வந்து அவ்ளோ ஹையா இருக்கும். It is coming around, and the value you should remember 10 to the power 7 Kelvin. Okay, அந்த அளவுக்கு temperature இருக்கும். Okay, இந்த processல. Next வந்து இந்த fission processல high radioactive elements இருக்கும், waste da it will be produced. ஆனா வந்து fusionல அவ்ளோ radioactive elements வந்து it was not there. Next வந்து இத யூஸ் பண்றது nuclear reactor atom bomb தான். And இந்த fusion வந்து sun stars எல்லாமே நடக்கிறது வந்து இந்த fusion தான். And also you can say hydrogen bomb. And in the reaction, in the fission வந்து controllable தான். ஆனா fusion வந்து it is very difficult to control. புரிஞ்சுதாடா everybody? So in the nuclear fission and fusion la we have discussed a few of the features. Okay, and the comparison you should know. These are the important points to remember. And now I hope we can go for solving the questions. Okay, before that Q value is also there. Okay, so Q value now okay, so இப்போ வந்து when I'm talking about Q value, many students க்கு வந்து இதல confusions இருக்கு. Simple I'm telling you. Okay, simple I'm telling you. இதுக்கு அப்புறம் if you understood na give me a heart. Okay, and the difference புரிஞ்சிடுச்சுனா you should give me a heart. In the nucleus, when I'm talking about nucleons, okay, in the proton, neutron எல்லாமே together are coming to a nucleus. அந்த பாயிண்ட்ல when it comes to nucleons, okay, in the nucleus la irukra elements oda, when I'm talking about nucleons oda elements, adu vandu combined achu, it is becoming a nucleus na, I will mention it as binding energy. Purinjida? Now what is q value when it comes to the combination of nucleus? Okay, so idla vandu you can just see that when we have what is it, two reactants is there, and basically that will be nucleuses. Nucleus da adukku vandu, I mean nuclei da adula irukum. So and the reactants irukum, adukku vandu product irukum. So anta time la in the process la there will be some mass defect will happen. There it was due to nucleons, and idhula irukkiradhu nucleus. Adha difference. Binding energy na nucleons la, I mean it is related with nucleons. Q value na, it is related with the nucleus. Okay, in the nucleus vandu combined achu and it is giving another product, or in the nucleons vandu nucleus vandu split achu, adukapram it is giving a product. Purinjida? So binding energy is related with nucleons and Q value is related with the nucleus or nuclei. Okay, so appadina in the Q value ngirudhu, as I mentioned, in the two reactants irukku, and the two reactants after fission or fusion, what happened, it becomes two different product. Okay, appadina idhula irukra total mass, which means mass of the reactants. Okay, mass, total mass of reactants na idoda mass plus idoda mass minus in the what to say, in the mass of the product, adula oru change irukum. Adha vandu what we are calling it as Q value. Okay, so on the time la there will be some mass defect, and that mass defect is converted as energy. Adha vandu Q value. Purinjidada? Purinjida? Yes, any issues? Could you please let me know in the chat box, everybody? Any issues, please let me know. I hope everything is clear, right? Yes or no? No issues. Fine. Thank you. Okay. Good. Appadina in the Q value, when it comes to, when we are talking about nucleus na, adula irukkiradhu Q value da, same equation in the sense mass of the reactants minus mass of product. Ange irukkiradhu total mass of the nucleons minus mass of the nucleus. So just imagine, and the case la process vanda saying da, listen carefully, everybody, your attention should be here. So what I'm telling you is ipo vanda we have the mass of the nucleus. Ana vanda whenever we are just considering mass of the nucleons, the mass of the proton, mass of the neutron vanda mass of nucleus. So idhila vanda reactants na enna, mass of protons plus mass of neutrons. Correct? Idhula product enna, mass, in the mass of nucleus da. Exactly similar way, adula irukkiradhu nucleons da, idhula vandu two elements da, A plus A. Okay, adula irukkiradhu and the product vandu mass of the nucleus da, idhula irukkiradhu B plus B. Appadina both cases la vandu how we will be finding it, it is nothing but the mass of the reactants minus mass of the product into C square. Purinchida, everybody? Everybody understood? Yes or no? Give me a fire in the chat box if you understood. Everybody? Yes. So, ipo vandu in the Q value positive na exothermic reaction da, which means it will be releasing a lot of energy in the form of heat, and Q is equal to negative na, adu vandu endothermic reaction. Let us go for the question. Ready na? Give me a fire in the chat box. Ready na? Arambikkalama? Why special 11 AM class? Evening la 12th students biology exam classes irukada, adunala da. Okay. Yes. Perfect. So let us go for the first question. Can you go for it? Are you guys ready? Ready? Yes. Now the question is, if the radius of aluminum 1327 nucleus is taken to be RAL, then the this we can just write it as RAL. Okay. Then the radius of tellurium 53125 nucleus is nearly, okay, you should find the radius of tellurium. So idukaga you should use only this equation R naught A to the power 1 by 3. Okay, now take for aluminium, all the values are there, R naught value on the, it will be anyway get cancelled if you are taking the ratio. So now you can just substitute the value. Simple on a question, and my students will rock. They will give me the answer in seconds. Quicker, you can give me the answer, guys. Just take the ratio and give me the answer. Go for the question, go for the solution. Simple, da, take the ratio. RAL and R tellurium. Mass number one, it is already given in the question. Quicker, you can give me the answer. Why you people are not becoming, what is it, the competitive spirit irukanoda, quicker to do the solution. Yes, I'm getting the answers. Everybody do it. In the equation mattum podu, you can do it. Yes, perfect. Very good. Yes, perfect. So appadi now we can just go for, we need what, tellurium. So I'm just taking this ratio. Okay, so while I'm doing it, R naught one the same, and A value for the tellurium, what is the A value? 125 the all to the power 1 by 3 divided by R naught into aluminum 27 all to the power 1 by 3. Appadina R naught will be get cancelled, and 125 one, it will come as 5, and this will be coming as 3. Appadina in the radius of tellurium one, the 5 by 3 into this one. Okay, and also sometimes, not always, sometimes they will ask the ratio. Okay, at the time careful in the question read panniko and write. Ipo sometimes they will ask radius of aluminium to radius of tellurium ratio. So idu you have to write it there. Yena you can see in the both the options are there. Okay, 3 by 5 oda irukku, 5 by 3 kuda irukku. So idha what I'm saying, silly mistakes. And the madri mistakes my students are not supposed to do. So adukagata I have given a hint. The binding energy per nucleon is maximum in the case of, now only we studied. Quicker, give me answer. Quicker. In seconds, in very few seconds you can give me the answer. Very good, Tarun. Yes, perfect. Yes, very good. So appadina we know that in the Fe, iron is the most stable element, so we can go for option B. Next, a nucleus has a mass number A. Okay, ஒரு nucleus இருக்கு, அதோட mass number வந்து A தான், atomic number வந்து Z தான், binding energy இருக்கு B. The mass of neutron and proton are Mn and Mp respectively, and the speed of it is moving with the speed of light. Which of the following expression correctly represents the mass of the nucleus? What we need? We need the mass of the nucleus. We need the mass of nucleus. Only you need to know the binding energy equation. Okay, and the binding energy is given as E. Appadina tell me what is the mass of the nucleus. Very simple question. If I'm writing the equation itself is going to be the answer. So adanala I'm not going to do it. So now it is your turn. Quick vandu you can give me the answer. Everybody, those who are watching the session, like the video, also share with your friends. Yes, very good. I'm getting the right answers. Perfect. மறக்காம சண்டே ஷார்ப் 10 o'clock join பண்ணிக்கோ இந்த மாதிரி we have to solve the questions. Perfect. So இதில் இருக்கிறது we know that A minus Z Mn, correct? Mass of the neutron plus Z MP, இதுதான் mass of, total mass of protons, minus M into C square da. So right now I'm taking that C square over here, okay, into C square. So C square I'm taking over here. Now இப்போ வந்து minus M we are going to make it as plus M. So what we have over here, A minus Z Mn plus Z MP. So அங்கே இருக்கிறது plus E by C square da. When it comes to here, it is given as B, right? Okay. So now we can go for B by C square. So we will be getting the answer as option A. Very good. Perfect, guys. Perfect. Alpha particle consists of? Simple question. Alpha particle consists of? Alpha particle consists of? Vika, give me an answer. Alpha particle consists of? Which is equivalent to? Which atom? Which element? Very good. So இது வந்து 2 protons and 2 neutrons இருக்கும். Okay, very good. So answer வந்து option D da. Now I hope you can read it. When a uranium isotope U-23592 is bombarded with a neutron, okay, it generates a krypton 8936, 3 neutrons also. Now what is the other element? And one thing is like it is not necessary that if a parent nuclei is split into 2, it is not necessary that and the 2 or 3 daughter nuclei want the same type parakanam. It is not necessary. It can be anything. Okay. So now you guys have to do one thing. So idala vandu what we are doing, 23592 plus 1 neutron na idudha vandu adoda representation. Idhula irukkiradha 1 we got it, crypto 8936 plus 3 neutrons irukku. Okay, now you can just balance in the mass number total vandu it should be 235. அப்படினா 235 plus 1 da இந்த reactants la irukku. Okay, 235 plus 1. So இங்க இருக்கிறது டோட்டலா 236 da. So இங்க 89 இருக்கு, இதுல வந்து 3 இருக்கு. So 89 plus 3, which means it is coming as 72. So 236 minus 72 will give the mass number over here. And இங்க பார்க்கும்போது 92, 36 and here it is 0. அப்படினா what is going to be the? Very good. So இதுல வந்து பார்க்கும்போது this one is coming as 144 and this one is coming as whatever be the element. This is coming as I hope it is 36, 56, correct? So in the element represent பண்றது வந்து barium da. So we can go for option D as the right answer. Now another question over here. Can you read the question? So the binding energy of atoms of element A and B are EA and EB. Okay, binding energy of these elements are given. So இப்போ வந்து the 3 atoms of the element B fuse to give 1 atom of element A. This fusion process is accompanied by release of energy E. So then EA, EB and E is related with 3 particles, 3 elements of B fuses. Which question, Manchu? The previous one. Very simple da. So adula vantu simple. Okay, let me just change. I hope others has written the question. So ipo vandu idula paakumbodhu, you know this is given 23592 and what is given, bombarded with 1 neutron. So I am just representing like this. Okay, and adoda result after this fusion, okay, or after this one, what happened? Idhula vandu it got daughter nuclei. Okay, adula vandu first one 8936 plus idhula mention பண்ணியிருக்க 3 neutrons. Okay, அப்படினா 3 neutrons I am representing. Now the thing is like, you should have one more daughter nuclei. Okay, so adukkaga you should find the mass number as well as the atomic number. So first one I'm checking on the mass number. So inga paakumbodhu 235 plus da, it should be equal to the mass number over here. So idhula vandu 3 neutrons irukku, so I have to write 3. Okay, 3 into 1 will be coming as 3 plus this x value. So appadina here you will be getting 236 minus 89 minus 3, which will be giving you x. And the value da 144. Same way in the case la 92 irukku, idu vandu 0 da, so you don't need to care about it. Next vandu inga paakumbodhu 36 irukku, inga irukkiradhu idoda atomic number vandu 0 da, so plus 0 plus idhula irukkiradhu, let me just write it as y. அப்படினா 92 minus 36 வந்து I will be get it as y. So அந்த value da coming as 56. So now we got இது வந்து 144 da, இது வந்து 56 da. So checking on this, இந்த option வந்து D da. புரிஞ்சுதா மஞ்சு? Any confusion on this question? Please let me know. Now guys, give me the answer. Oh my god, too many things which is not good. Yes, very good. So others, you can give me the answer for this question. So read the question. So idhula vandu paakumbodhu binding energy of an atom is A is coming as EA and the other one is B. Okay, now 3 atoms of element B. Okay, 3 atoms of element B is combining and giving an element what? A. This fusion process is accompanied by a release of energy. Okay, so ipo vanda 3EB vanda converted as EA. அப்படினா இதில் இருக்கிற அந்த energy difference da in the released energy. So 3EB da in the energy irukku initially, and adukapram it converted as one element, adoda energy vandu EA. அப்படினா அதில் இருக்கிற difference da this one. So which equation is correct? Which equation is going to be correct? We can say option C. Very good. So it's sorted. So now we have the another beautiful chapter which is named as Semiconductor. Are you guys ready for Semiconductor? Yes or no? Or should we go for a 10 minutes break? After that, should we start Semiconductor? Yes or no? Tell me in the chat box. Otherwise, straight we can start this. Yes, very good. See the option C, the correct answer. Are you guys excited for semiconductors? Yes or no? Or like other chapters, ma'am, we are not even excited. 5 minutes break. So let us go for a 5 minutes break. So ipo vanda okay. So let us just come back by 12:20. Okay, so let us we can just take a break and we can come back. Okay, Vada? Ready? And come at sharp 12:20. Everybody is here. Yes or no? Continue பண்ணலாமா? Ready? Ready? Everybody? Tell me, ready na? Give me a fire da. ஆரம்பிக்கலாமா? Why you people are not responding? You're just watching, ma'am. We will watch only. We won't say anything. Then I will also look at you guys. Let's see who will win. Okay, so இப்போ வந்து semiconductor chapter தா. Semiconductor chapterல first we have to understand the energy bands. Okay, so energy bands na in the electrons இருக்கிற same orbits la it will be having some energy levels. So இப்போ வந்து let us say if I'm talking about an isolated atom. Okay, isolated atom or isolated ion na அதோட energy levels வந்து or energy levels இப்படி தான் இருக்கும். Okay, it will be just a single line. ஆனா வந்து we know that whenever we are talking about a solid crystal, adula வந்து it cannot be isolated. It will be interacting with the rest of the elements. So அந்த டைம்ல இந்த energy levels வந்து it will be having a lot இந்த மாதிரி இருக்கும். இந்த energy levels வந்து இப்படி இருக்கும். So together we will say இது வந்து nothing but the energy band. Okay, so first we should know what is energy band. It is nothing but the grouping of this different energy levels. Okay, so the grouping of different energy levels is known as the energy band. Okay, so when I'm talking about energy band, I have to talk about the conduction band. I have to talk about conduction band as well as valence band. Okay, so now the thing is like when I'm talking about this conduction band, first thing is conduction band in the free electrons irukum. Conduction band as well as valence band. Okay, so idhula da vandu nama free electrons irukum and it can be empty also. It is not necessary that it should be packed always. It can be empty as well. So idhula irukkiradhu vandu nama valence electrons da and it cannot be, okay, it cannot be empty. It is either it will be fully packed, otherwise it will be partially filled. Okay, so it can be partially or completely filled, but ana vandu in the conduction band vandu even it can be empty as well. Okay, so now coming to the conduction band. Okay, so we know that adula da in the free electrons irukkiradhu. So in the valence band il irukkira electrons it will get some extra energy and it will gain some energy and it will come to the valence band. Okay, so this is what the basic idea about the conduction band as well as the valence band. Okay, in the conduction band la da in the free electrons irukum, valence band la da in the valence electrons irukum, and in the valence band vandu partially or completely filled ah irukum. Conduction band vandu empty ah irukkalam, partially filled ah irukkalam. Okay vada, so idu da vandu basic idea. Next vandu once we understood about this valence band and conduction band, we can just straightly for something very new to us, that is nothing but forbidden energy gap. Okay, forbidden energy gap. This is nothing but the gap between conduction band and the valence band. So ipo vandu inda madiri da inda conduction band and valence band irukraduna. Okay, so idha vandu namma valence band. Okay, இதுதா வந்து conduction band na இந்த gap da, okay, இந்த gap da nothing but our forbidden energy gap. Depending upon the forbidden energy gap da, okay, depending upon the forbidden energy gap da we will be mention whether it is a conductor, semiconductor or insulator. இப்போ வந்து when I'm talking about a conductor na in the valence band and conduction band வந்து overlap இருக்கும் இல்லனா இந்த energy gap வந்து I can say it will be coming as 0. Okay, so conductors what is happening in the conduction band and valence band வந்து it will be overlapped or let's say and the gap வந்து 0 தான். When it comes to semiconductor, in the gap should be for semiconductor it should be less than 3 electron volt. Okay, in the band gap வந்து it should be less than 3 electron volt na we can say that and the element illana and this one the crystal வந்து it is nothing but a semiconductor. Now you guys tell me for an insulator how you tell about this or how you will define insulator in terms of energy gap. Tell me everybody. Everybody tell me. Everybody tell me. இப்போ வந்து in the case insulator na what will happen in the energy gap should be greater than 3 electron volt. This is how we will be defining the insulator, semiconductor and conductor. Very good, conductor in terms of energy gap. So first one we will be focusing only on the semiconductor part. So semiconductor la what we have mentioned in the semiconductor la we have mentioned idoda energy gap வந்து less than 3 electron volt da and idhil irukra in the coefficient of temperature, the temperature coefficient we have studied in current electricity adu வந்து negative ah irukum. So negative na when temperature increases what will happen to resistance or resistivity? What will happen? Tell me. Just remember from current electricity. When temperature increases for the semiconductor, na in the resistivity ki enna agum? It will reduce. புரிஞ்சுதா? So when temperature increases, in the resistivity வந்து reduce ஆக போறே. Okay வாடா? Next வந்து at 0 Kelvin, this will become a insulator. Okay? So when I'm talking about a semiconductor, adula vandu energy gap vandu it should be less than 3 electron volt and adula vandu in the alpha value vandu negative da adunala when temperature increases resistivity decreases which means in the conductivity increases. Correct? In the conductivity increases and at 0 Kelvin la vandu it will be act like a insulator. Next vandu idhil irukra charge carriers. Okay, idhila irukra charge carriers na electrons mattum illa vera yaar irukku in the semiconductor la charge carriers na tell me everybody what is the other charge carrier? It is nothing but the hole. Okay, so idhula vandu free electrons as well as holes irukum in the charge carriers for free electrons irukum as well as in the holes irukum. புரிஞ்சுதா? Very good Manju, very good Tarun. Okay, so இப்போ வந்து we understood charge carriers na in the free electrons holes எல்லாமே இருக்கு. So now the turn is for the holes. Okay, so when I'm talking about hole, okay, hole இது வந்து positive da. We usually mention it is as a positive. When the covalent bond breaks, if electrons will become free or it will escape from the atom, then definitely there will be a vacant space. And the vacant space da in the whole we are representing it. Purinjidada everybody? Purinjida. So for a whole we can say that it is nothing but a positive. It is representing a positive charge. Yena in the covalent bond break பண்ணும்போது அதுல இருக்கிற electron வந்து escape ஆக போற அந்த space அந்த escape ஆகிற momentல there will be a vacant space. அந்த vacant space தான் nothing but this hole. Purinjida? Everybody understood? Now we know that we have germanium, also we have silicon. These are the things we are majorly taken for the semiconductor. So idhula irukkiradhu, the thing is like in the energy band gap vandu it is small for this thing. Okay, in the germaniumthukku vandu 0.7 electron volt da, siliconukku vandu 1.1 electron volt da in the energy gap. So adanala da most of the cases la vandu we are using germanium and silicon. That doesn't mean like the rest of the components are not semiconductors. It is also semiconductor. Ana when it comes to germanium and silicon, adoda energy gap vandu avlo, that is very 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 small. Okay, so adanala da we are considering always this germanium and silicon, not due to any other reason. Purinjidada? Purinjidichana, give me a fire in the chat box, everybody. Everybody give me a fire if you understood. Everybody. Yes. So these are the basic idea. Now we got an idea about the the conductors as well as the insulator, semiconductor, everything on the basis of whatever we have mentioned. Next we are going for the types of semiconductors. So inga irundha we are starting. Okay, types of semiconductors. So idhula first one is nothing but intrinsic. Okay, next is nothing but extrinsic. Okay, intrinsic and extrinsic semiconductor is there. So when I'm talking about intrinsic na, adoda meaning very simple, pure semiconductor, which means adula silicon na silicon mattum da irukum, germanium na germanium mattum da irukum. Extrinsic na, I wanted to increase the conductivity. Okay, I wanted to increase the conductivity. So adanala idhula impurity irukum. So which means it is not pure. So right now we have two hi, good morning. So idhula we have two, sorry. Okay, so idhula we have two types of semiconductor. First one the intrinsic da, so adula pure semiconductor, it is actually the pure semiconductor. And extrinsic na adula impurity irukum. Okay, it is not pure, it will be having impurity. Yes, coming to that. Okay, yes. So now we understood we have two. Next one, I will be focusing on the intrinsic semiconductor. As I mentioned, silicon na silicon mattum da irukum, germanium na germanium mattum da irukum. So idhula inda ipo silicon la usually the 14th element in the semiconductors na 14th group la irukra elements da. So in the silicon la 4 valence electrons irukum. Correct? Idhula 4 valence electrons irukum. So ipo what will happen whenever when we are not giving any temperature. Okay, intrinsic la whenever we are not giving any temperature na, no change, it will act as a insulator as we have discussed. Now what we are doing? We are giving some temperature. ஏனா இந்த வேலன்ஸ் எலக்ட்ரான்ஸ்க்கு, ஓகே, இந்த வேலன்ஸ் எலக்ட்ரான்ஸ்க்கு கொஞ்சம் எனர்ஜி கிடைச்சா போதும், அதுக்கு ஃப்ரீயா இந்த கிறிஸ்டலுக்குள்ள இட் கேன் மூவ் எனிவேர். புரிஞ்சுதா? Everybody understood? Listen carefully. So இப்போ we have a silicon over there. Okay, so அதுக்கு 4 valence electrons இருக்கு. இப்போ இது covalent bond ல இருக்கு. Okay, இது இந்த neighboring silicon ஓட covalent bond ல இருக்கு. புரிஞ்சுதா? So now the thing is like in the 4 electrons irukalla, when I'm giving the temperature, which means I'm giving heat energy, and the heat energy nala in the covalent bond will, okay, it will break the covalent bond. Okay, intrinsic semiconductor la what is happening when we are increasing the temperature in the covalent bond it will get broke. Appadina there will be a free electron as well as there will be a vacant space. Okay, there will be a vacant space. புரிஞ்சுதாடா everybody understood? So right now covalent bond break ஆச்சு. அதுக்கப்புறம் what we have mentioned, அதுல அந்த electrons has escaped, right? அந்த escape ஆன pointல there is a vacant space. அதுதான் whatever we have mentioned it as the hole. So இப்போ கூட if you are checking on it, அந்த free electronsக்கு பதிலா அங்க வந்து ஒரு positive charge இருக்கு. So total charge of the crystal, or let's say total charge வந்து still neutral தான். கரெக்ட்டா? Still வந்து neutral தான். ஏ free electrons இருக்கு, அதுக்கு equivalent ஆன positive charge கூட இருக்கு. Okay, இப்போ வந்து whenever I'm increasing the temperature na அதுல வந்து free electrons, okay, இந்த electron valence electron வந்து it is coming as it is becoming free. அப்படினா அங்க இருக்கிறது ஒரு vacant space கூட இருக்கு. So அதனால always இதோட neutrality will be maintained. Important point தான் note பண்ணிக்கோ. If there is a free electron, there will be a vacant space also. அதனால I can say that இதோட total charge வந்து இல்லனா I can say இதோட neutrality வந்து always maintains. Okay vada? Okay va? Understood? So total charge வந்து always வந்து neutral ஆக போறே. புரிஞ்சுதா? Next வந்து as I mentioned, இதுல வந்து free electrons இருக்கும், இதுல வந்து holes இருக்கும். Okay, one free electron na அதுக்கு equivalent there will be a hole as well. அப்படினா number of electrons will be equal to number of holes. Important point, note பண்ணிக்கோ everybody. And till this, if you are understood, give me a fire in the chat box. Everybody give me a fire in the chat box. And those who have joined right now, like the video, also share with your friends. So இப்போ வந்து number of electrons which is equal to number of holes. Okay, so intrinsic semiconductor la, if I'm multiplying, okay, if I'm multiplying this Ne into Nh na, this will be coming as Ni square. Okay, இப்போ வந்து இந்த Ne வந்து I'm representing it as Ni. அப்படினா Nh also coming as Ni. Ni na the concentration. Okay, அது வந்து nothing but the concentration of the intrinsic. Okay, அந்த intrinsic semiconductor ல இருக்கிற I mean in the carriers oda concentration da. So adukku வந்து this is what we are calling it as the mass action law. You should study this as well. Okay, we can expect some mathematical questions also from here. So mass action law, Ne into Nh, which is equal to Ni square. Okay, next வந்து important ஆன process தான். Understand everybody. இதில் இருக்கிற current, okay, இதில் இருக்கிற current தான் we are going to discuss. So இப்போ வந்து பார்க்கும்போது let us say I'm just fixing it like this, then you will be get a clarity. Okay, so right now here we have some electrons. Okay, here we have some electrons. Okay, புரிஞ்சுக்கோ. இப்போ வந்து we have given some energy. So அதுல இருந்து what happened in the electron வந்து escaped. கரெக்ட்டா? So அப்படினா இங்க இருக்கிறது vacant space தான். புரிஞ்சிடுச்சா? இங்க இருக்கிறது vacant space தான். Okay, so now this becomes a vacant space. Okay, so what will happen? இந்த electron பார்க்கும்போது இந்த vacant space இருக்குல்ல, so it will immediately move towards here. I hope it is understood. So இப்போ வந்து ஒரு electron வந்து escape ஆச்சு, அப்படினா another electron will replace the vacant space. அப்படினா now what happened? So இப்போ வந்து பார்க்கும்போது let me just go for 3 or 4, then it will be easy for me to draw. Okay, check it again. So இப்போ வந்து இதுதான் வந்து நம்ம crystal. Okay, so இதில் இருக்கிற electrons தான் I'm showing over here. Okay, so இப்போ வந்து இந்த electron வந்து escape ஆச்சு. அப்படினா what will happen? Here we will be having a vacant space. இங்க electrons இருக்கும், other 3 electrons இருக்கும். Correcta? Now what will happen? What I said? In the electron வந்து it will replace the vacancy. Okay, so the adjacent electron will replace the vacant space. Okay, அப்படினா இந்த electron will move towards here, then this will become like this. Okay, so this is occupied, in the vacant space inga irukum, and inga again one electron irukum, inga again one more electron irukum. Purinjudha? So now the vacant space is here. Now tell me again the same process. In the electron vanda, it will again replace the space. அப்படினா what is happening guys? So இங்கே ஒரு electron இருக்கு, இந்த electron வந்து it is replaced, இங்க vacant space இருக்கு, இங்க again electron இருக்கு. Next again what will happen? Again this will replace. அதனால again we can see that இங்க இருக்கு, இங்க ஒரு electron இருக்கு, இங்க ஒரு electron இருக்கு, இங்க தான் vacant space. Now you people have to tell me, okay, இதுல இருக்கிறதுல இந்த electrons ஓட flow வந்து towards the right hand side இல்ல left hand side? Tell me in the chat box. Quick, you can give me. Okay, in the case பார்க்கும்போது what you understood, இந்த electrons ஓட flow வந்து right hand side இல்ல left hand side? Direction of flow of electrons. So you can just see that in the electrons வந்து எப்படி it is going? Give me a quick answer da. I hope you understood this. இல்லனா சொல்லிக்கோ, I will again explain. Please let me know. Everybody. So idhula vandu paakumbodhu what is happening in the direction of in the electron vandu it will be moving towards the very good, it is moving towards the right hand side. Okay, right hand side. Appadina you should tell me the direction of the current due to electron flow. Can you just give me the answer for that? The direction of very good, everybody is just understanding each and every concept. In the electrons oda flow on the right hand side da. Appadina you guys have to tell me in the electrons oda flow nala there will be a current, correcta? Charges oda flow da current. Appadina idhula irukkira in the charges oda flow nala, in the electrons oda flow nala there is a current. Adha vanda I have represented it as IE. Now you guys have to tell me in the IE oda direction towards which side? Towards which side? Tell me the answer. Everybody tell me the answer. In the case la vanda what is going to be the direction of the current due to the electron flow? அது வந்து exact opposite இருக்கும். So I can say இது வந்து left hand side. Very good. ஏனா இந்த negative charges ஓட flow ஓட opposite directionல தான் இந்த current இருக்கும். So electrons வந்து rightல move பண்ணிட்டு இருக்கு, அதனால இந்த current வந்து it will be towards the left hand side. Now you have to, sorry again, one second guys. Okay, so now you guys have to tell me another question. The direction of flow of holes, it is towards right or left? In the hole order direction, to which direction this hole is moving? Right side illa left side? Electrons oda flow vandu whatever you have Z is correct, adu vandu right hand side la da. Okay, in the electron vandu it will move towards the right. ஆனா வந்து இந்த ஹோலுக்கு என்னாச்சு? இந்த ஹோலுக்கு என்னாச்சு? Hole, what is the direction of flow of holes? அது வந்து left hand side தான். So இது வந்து current due to hole தான். அது கூட it is nothing but left hand side. புரிஞ்சிடுச்சுடா? புரிஞ்சுதா? Very good. And அது வந்து positive charge தான். So currentக்கும் வந்து same direction இருக்கு. So இப்போ வந்து if I am finding the net current na, I will get IE plus IH. Again, important dana relation. Okay, so now what we were discussing, when we are giving temperature for a pure semiconductor, okay, or intrinsic semiconductor, the covalent bond will break. Okay, covalent bond will break. After that, the electrons, the valence electron will escape, and due to that what is happening? There will be a vacant space created. Next, what is happening? The adjacent electron will replace the vacant space, and the vacant space will shift towards the opposite direction of electrons. Okay, so now the important thing is coming over here. Due to this, there will be two currents. One is due to the electron flow as well as the hole flow. Okay, and the direction of current will be opposite to, okay, the direction of current will be opposite to electron flow, and here the direction of current will be same as the direction of flow of holes. Okay, so if you understood this now, the basic thing is done. Okay, as I mentioned, if you want it, you can just note it down. I'll give you 1 minute, and meanwhile I'll be just take a bottle of water and I will come. Okay, so note panniko, each and everything is, you can just write in your own words and just try to make a proper note. Yena vanta last minute la vanta you cannot go for it. Okay, it is for this 12th batch, 12th grade only, Manju. Bio classes will be happening only for 12th till the exam. Okay, till that chemistry and physics will be in the daytime. Okay, just give me 2 minutes, I'll take water and I'll come. So meanwhile you can write it down. Everybody is done? Yes or no? Let us continue. Yes or no? Give me a answer in the chat box, everybody. Okay, so now the thing is, like, we understood in pure semiconductor, this is the thing which is happening, and also we understood the net current is nothing but the current due to electron flow, the current due to the hole. This is an important relation, and you should understand why we have added these two currents and why we got this relation. Adu vandu important da. Next one we know what is the current density equation. Do you guys remember? Do you guys remember what is the equation for current density? I hope you guys remember current electricity. It is nothing but NE into VD. Correct? So, this is the equation we have studied. So, intrinsic semiconductor la when we are finding this, we will get to know this will become in the drift velocity both the cases different da. So we have to deal it separately. So in the current density it will be coming as NE into VDE, which means the drift velocity of electrons plus the drift velocity of the positive charge charges, that is nothing but our our holes. Okay, next one the conductivity da. So conductivity will be coming as mu Ne. These are the equation we have already studied in the current electricity chapter. So ipo vandu in the cases la what is happening what is happening, we can just say in the conductivity will be coming as mu E, which means due to the electron, and the mobility due to the hole. So you can just replace the equation. Okay, in the sigma oda equation vanda you can replace it like this. Sigma will be coming as mu E plus mu H into Ne. Purinjidada everybody? Yes or no, understood? So next one the nothing but dopants. Okay. So in the case when I'm talking about dopants, now we have mentioned. Okay, idhula in the extrinsic semiconductor irukku, we will be adding the impurities. When we are adding impurities, and the impurities, what are the impurities we are adding? We will be call it as dopants. The impurities we will be call it as dopants. Purinjida? Yes or no? So ipo in the dopants okay, in the dopants while we are choosing the dopants, there should be, we have to check few things. First in the size of the dopant must be comparable with the crystal. Okay, illana it will affect the crystal lattice. So adanale in the size should be comparable. Okay, the size should be comparable. And also we cannot add a huge amount of impurity. Impurities add pannina definitely in the conductivity increase agum. Analum we cannot add that much. Okay, so idhula major when we are choosing the dopants na adhula major, as I mentioned, in the size of the particle should be comparable, and it should occupy only a very few space. Okay, it should occupy only a very few space of the atom. Okay, of the semiconductor. So this is the dopants we need to consider. Next is the ratio, which means if I'm taking a silicon atom and I'm adding the impurity na, okay, so on the impurity versus and the semiconductor ratio na, it will be coming around 1:10 to the power 8. Okay, this is the ratio, the impurity to the semiconductor ratio, it will be coming as 1:10 to the power 8. That is the ratio. And as I mentioned, impurity it will increase the conductivity. Analum, above we cannot go for adding the impurity. As I mentioned, it should occupy few space only. Okay, so these are the things which we should know about the dopants. Okay, Vada? Everybody is ready? Yes or no? Tell me in the chat box, everybody. Yes or no, da? So now we are going for the classification, intrinsic and extrinsic semiconductor. So when I'm talking about intrinsic, na, as I mentioned, this is pure semiconductor. This is impurities. Okay, this is impurities. So comparing with extrinsic, this conductivity will be less compared to the conductivity of this one. This will be very high. Okay, and in the intrinsic semiconductor practically we are not using much. Idhula practically we are using this for many things. And also major idhula number of electrons and number of holes same agapore. Idhula what is happening? It is not equal. Okay, and in this case we can say that in the energy gap it is less the even for intrinsic and extrinsic, comparing with the extrinsic semiconductor energy gap innum kammi da. Okay, so this is the major differences. Intrinsic semiconductor we can say pure semiconductor da. Adula the conductivity is less, practical uses less da, and also idhula number of electrons and holes same da. and when it comes to extrinsic semiconductor la adula vandu in the silicon germanium in the semiconductors la vandu we are going to add the impurities, and conductivity vandu increase agum. I mean it is high which comparing with the intrinsic semiconductor. Practical uses kaga we are using this one only, and in the concentration vandu different irukku. Okay, so now let us go for the extrinsic semiconductor. As we discussed, adula vandu we are adding the impurities. When I'm talking about adding the impurities, now I have to tell there will be two types of extrinsic semiconductor. So as I mentioned, in the semiconductor vandu we have splitted as two. First one the intrinsic da, okay, and this was nothing but extrinsic. Okay, now this is having two, that is nothing but N type as well as P type. Okay, so in the N type na we are adding 15th group element. Idila vandu we are adding 13th group element. So idila vandu extra electron irukku. Okay, it will give an extra electron. Idila vandu free space irukku. Okay, so adanala I can say that in the N type la vandu the concentration of electron vandu high ah irukum, and idila vandu holes vandu the concentration of holes vandu high ah irukum. Okay, so in the N type and the P type semiconductor la vandu the major ana differences na N type la we are adding 15th group element. Okay, so the thing is like we are replacing any of the silicon or germanium with the what is our 15th group element. So adala vandu extra free electron irukum. Okay, so and the madri if we are adding more number of impurities na more semiconductor atoms will be replaced by this 15th group element. So adanala conductivity will increase. Okay vada, so adha vandu important ana point, and idhula vandu extra electron nala we will say idu vandu donor atom da. Okay, so we will call it as donor, and now let us go for the N type. Okay, so in the N type as I mentioned we are adding donor impurity or otherwise pentavalent impurity or otherwise 15th group element. Okay, 15th group element. So idha vandu the impurity what we are adding. So idhula vandu we are actually replacing. Okay, we will replace any of the semiconductor atom to the 15th group element. Okay, 15th group element. So appadina adula vandu extra electron irukum. Okay, idhula vandu extra electron irukum. In the extra electron da it will go to the conduction band. Okay, so idhula vandu as I mentioned the concentration of electron vandu high aga pore. Definitely idha vandu majority charge carriers. Okay, majority charge carriers. Aanalum these are all happening at high temperature. Adanala same process what happened in the intrinsic, what is happening, there will be some covalent bond will break because of the high temperature. In the process vandu avlo temperature la, okay, avlo temperature la da this is happening. So adanala in the whole order concentration vandu it will be there, ana vandu anta alavukku irukadu. So adanala I am calling it as minority charge carriers. Purinjudada. So now thank you so much. Okay, so ipa vandu we understood in the when we are adding an impurity to a silicon, okay, a silicon semiconductor, so adula vandu any of the silicon will be replaced. Okay, so அந்த பிளேஸ்ல வந்து pentavalent atom தான் ரீப்ளேஸ் பண்ணியிருக்கேன். ஸோ அதில் இருக்கிற ஒரு எலக்ட்ரான் வந்து ஃப்ரீ ஆக போகிறேன். ஸோ அதனால அந்த எலக்ட்ரான் இருக்கும். அண்ட் ஆல்சோ இது வந்து ஹை டெம்பரேச்சரில் தான் இந்த ப்ராசஸ், இந்த இம்ப்யூரிட்டி ஆட் பண்ணுறது வந்து அவ்வளோ டெம்பரேச்சர் இருக்கணும். ஸோ அதனால யூஸ்வலாக இருக்கிற இந்த கோவலண்ட் போண்ட் வில் பிரேக், அதில் இருந்து வேக்கன்ட் ஸ்பேஸ் இருக்கும். ஸோ அதனால மைனாரிட்டி சார்ஜ் கேரியர்ஸாக இந்த ஹோல்ஸ் கூட இருக்கும். புரிஞ்சுதா எவ்ரிபடி? ஓகே, அண்டர்ஸ்டுட்னா கிவ் மீ அ ஹார்ட் இன் த chat box. Okay, so adanaala idhula vandu holes irukum electrons irukum ana electrons vandu majority charge carriers, holes da vandu minority charge carriers. Okay, இது important point தான். In the holes it is due to the process. Okay, அந்த processல இருக்கிற high temperatureனால தான் இந்த holes இருக்கும். அது வந்து minority charge carriers தான். We will be call it as minority charge carriers. Okay வா? And இதில் இருக்கிற இந்த conductivity எல்லாமே we can just mention it as sigma into sigma is equal to n into E into what to say, and the n வந்து it is nothing but our concentration of the electron. Very good, thank you. So next one the p type da. P type we will be call it as acceptor atom, okay, and the impurity, or trivalent, or else we can say 13th group element. Okay, idhula kuda what is happening, silicon will be replaced by a 13th group element. Okay, so idhula vandu paakumbodhu there will be vacant space. Okay, vacant space is created. So adanaala number of holes vandu adhigama irukum. So in the case la majority charge carriers vandu in the holes da. Next vandu in the Ne da idu irukum. This is nothing but the minority charge carriers. Okay, and again the same process whatever we have mentioned in the previous case. Okay vada, and idhula vandu if you are finding this conductivity na, and the conductivity oda equation vandu NH into E into Ne mu H. Idu da vandu in the conductivity oda equation. Everybody is understood, yes or no? Yes or no? Tell me in the chat box. Adukapram we can just go for the PN junction. So now you can tell me. Yes, thank you so much, yes. Okay, so now we are going for the PN junction. Okay, so in the PN junction la, very simple, we will take a P type, we will take a N type, and we will combine together. Okay, so when it comes to together, we know in the P type la holes da adhigama irukum, correct? And N type la vandu in the negative charges electrons da adhigama irukum. So when we are keeping it together, what will happen? Just after a few seconds, you can just see that in the P type la irukra positive charges vandu it will accumulate over here, and in the idudha vandu P type, idudha vandu N type. So idhil irukra electrons vandu it will accumulate at this side also. So there will be a recombination of positive and negative charges, or let's say this hole and electron pairs will be formed in between the junction. Okay, we are taking P, we are taking N, and we are keeping it together. Instantly what will happen? In the electron hole pair will be formed. Okay, so first thing is the electron hole pair will be formed. Okay, so gradually what will happen? Again this layer will become little bit more wider. After that, even if an electron is try to come this way, okay, even if an electron is try to come this way, and the point la kuda what is happening in the electron vandu it is moving towards na inge irukkiradhu negative charge da. So in the electron nala it cannot go through this barrier. புரிஞ்சுதா? So when we are keeping it together, in the P irukku N irukku keeping together, electron hole has been formed. So adukapram again in the electrons vandu they will try to go through this barrier. Ana it cannot. Yena inga vandu strong negative charges irukku. Same will happen for holes also. In the holes vandu they will try to move towards the yena vandu inga irukkiradhu electrons da. So in the holes vandu it will try to come here. Ana inga irukkiradhu huge positive charge da. It will stop the holes also. So beginning ila due to majority charge carriers, there will be a current flow. Correct? There will be a current flow. That's whatever we are calling it as the diffusion current. Okay, this is nothing but the diffusion current. And in the diffusion current is due to only one thing. It is due to the majority charge carriers. And eventually, due to the potential barrier developed in the junction, the majority charge carriers cannot passes through it. So adinala in the diffusion current it will again reduce and eventually it will become zero. Okay, wow? Everybody understood? So now we have understood in the beginning in the electron hole pair irukum. So on the time we can say that these electrons will move from this n side to p side. Holes will move from p side to n side. Ana after some கொஞ்சம் டைமுக்கு அப்புறம் if you're checking on it இங்க ஒரு barrier form ஆகும். அதுக்கப்புறம் இதுக்கு it cannot travel. Okay, now I'm just focusing on the minority charge carriers. ஏனா இதுல we know that there are some minority charge carriers. In the p type there will be few electrons. Okay, and in the n type there will be some positive holes as well. So adinala what is basically happening after some time there will be because there is a potential barrier formed due to that. Okay, due to the potential barrier an electric field is formed. Okay, an electric field is formed and the range of that field is coming around approximately 10 to the power 5 volt per meter. Purinjiko, due to this potential barrier, there will be an electric field produced over there and adoda range and the value important that 10 to the power 5 volt per meter. Idanala, due to this minority charge carriers will start flowing from what is in the n type in the positive charges, p type in the negative charges, and eventually it will be produce a drift current. Okay, eventually it will be produce drift current. Purinjada, everybody understood? So we were talking about p-n junction. So p-n junction la we know first the electron hole pair will be formed in between the junction and it will create a strong electric field. A potential barrier will be developed. Adanala konjam time kapram in the majority charge carriers cannot pass us through the barrier. Okay, so till that point the current is due to the majority charge carrier, so we will call it as diffusion current. Adukapram in the strong electric field in the minority charge carriers will start flow. Adukapram and the current we will be call it as drift current. So in the p-n junction we have two types of current and the two types of current are the diffusion current as well as the drift current. Okay, and in the potential barrier order, width is approximately coming as 10 to the power minus 6 meter. Okay, so this is another important thing. And in the potential barrier for the germanium it is coming as 0.3 volt and for the silicon it is nothing but 0.7 volt. Don't be get confused with the values. So idla in the silicon order value 0.7 volt da, which means when we are taking p type and n type for silicon na adula what will happen when it becomes 0.7 volt na, then these electrons and hole cannot make pairs. Okay, germanium innum konjam da irukku, that is coming as 0.3 volt. Everybody understood? Understood na? Give me a heart in the chat box, everybody. And those who have joined new, you can just like the video, share this video with your friends also. Done. And now we will be representing. This is how we used to represent the diode. Okay, this is how we will be representing. This is on the positive side, this is on the negative side. This is how we will be representing a diode. Everybody got it? Yes or no? So in the values one the important in the electric field produced one the 10 to the power 5 volt per meter, and on the depletion layer order width one the potential barrier there will be a depletion layer will be formed in between. So adoda width one the 10 to the power minus 6 meter da adikapram we have studied about the values for germanium and silicon as well. Okay, now we are going for the PN junction diode. Okay, so in the PN junction diode, we have to go for forward bias as well as reverse bias. Okay, forward bias as well as reverse bias. Before that, just give me 2 minutes. I will just come in 2 minutes. Okay, just give me 2 minutes. Adikapram we can just go for the PN junction diode forward and reverse bias. So now we are going for, yes, we are going for it, okay. So now we are going for the PN junction diode. So adala first we will deal with the forward bias. Okay, we are going to discuss with the forward bias. Forward bias is very simple. So this is the PN. Right, inga vanda P irukku, inga vanda N irukku. So in the P side vanda we will be connected with the positive terminal of the battery, and biasing means just we are adding or just we are giving the battery. That's it. Okay. So idhula vanda forward bias na we will be giving P side, P type to positive terminal, N type to the negative terminal. So in the case we can see that first of all, when this P and combination comes in, there will be a depletion layer formed. okay, depletion layer formed. We know adoda range வந்து 10 to the power minus 6 meter da. We can say that this is a layer which is having made up of immobile positive and negative charges, or let's say positive and negative, or let's say electron and hole. Okay, so in the depletion layer irukum. So now as I mentioned, when it comes to germanium na, germaniathukku it is coming as the, okay, it is coming as the 0.3. so idhula vandu negative charges irukum, inga vandu positive irukum. so appadina in the field order direction vandu ippadida, and here it is exactly in the opposite direction. So now I'm just talking about the germanium. Germanium in the knee voltage vanda, it is coming as 0.3 volt. Now the thing is like, let me just say, I am giving a voltage which is 0.2 volt. Then what will happen? We know that ipa vanda in the 0.3 vanda in the direction la, and 0.2 vanda in the direction la. Appadina effective still on the potential irukum. Now again we are increasing to 0.3, 0.4. Then what happened? Definitely vandu in the depletion region vandu it will be again distorted, and what will happen? The electrons and holes can move through the p and n type. Okay, so now germaniathukku vandu as I mentioned 0.3 volt da, and in the germaniathula we can say that if we give a potential more than 0.3 volt na, again a rapid increase in the current flow we can see. Okay, we can see, which means in the barrier vandu break aachu. Okay, here only 0.3, ana vandu I'm giving 0.6. Appadina idu in the electrons in the side la irukra electrons ku vandu it can move from this side to this side. It can break, or let's say it can cross the depletion region. Okay, so adha vandu germaniathukku, or let's say even when it comes to silicon na, if you are giving a voltage which is more than 0.7 na, definitely vandu we can say that it will be there will be a flow of current will happen. அது வந்து diffusion current da, ஏனா வந்து majority charge carriers க்கு வந்து it can cross each other. Okay, so next வந்து when doping increases. Okay, when doping increases, understand this point is very important. In the doping increases now, what will happen to the depletion region? Whether it will increase or decrease, it will be obviously in the depletion region it will reduce. Okay, so in the point kuda important da when it comes to the forward bias, and in the forward bias la irundhu in the current flow irukku, and the current flow da range vandu milliampere da. Okay, this current is due to majority charge carriers, adha vandu we are calling it as diffusion current. Adula vandu we can say that in the current oda range vandu milliampere da. Next vandu reverse bias. Okay, reverse bias illa we will just change the polarity. Okay, so idudha vandu p type, idudha vandu n type, and p type ku we will be giving the negative, and here for the negative n type ku we will be giving the negative terminal. Appadina in the case illa what is happening? There will be initially as I mentioned beginning la vandu in the depletion layer vandu form aachu. Adukappuram what is happening? Adukappuram definitely inge irundha when we are looking on it in the madri da both will have the same direction. Okay, in the field order direction vandu same da. Adanala in the reverse bias case la up to a point there is no problem. Again and again if you are increasing the voltage na, there will be a breakdown, which means the depletion layer will break down by itself. Okay, break down by itself. So idudha vandu we are calling it as the breakdown voltage. Okay, idudha vandu breakdown voltage. So at the time there will be a current flow in the depletion layer vandu it got destroyed, right? At the time there will be a current flow, and on the current flow வந்து it will be in the ratio, or let's say in the order of microampere. Listen carefully, in the range வந்து important தான், அதனால தான் I'm highlighting it again and again. Previous case la forward bias la there will be a current flow, and the current flow is due to the majority charge carriers, adoda range வந்து milliampere da. When it comes to reverse bias, what is exactly happening in the depletion layer வந்து தனியா it is going to destroy, or let's say break down ஆக போற. So அந்த breakdown voltage இருக்கு, and due to that, okay, அந்த அந்த voltage வந்து அந்த barrier வந்து போச்சு, அதனால there will be a current flow. Till that point there is only one current flow, which is due to the minority charge carriers. இப்போ வந்து there is a current flow, அதோட range வந்து it is coming as the microampere. Okay, and we will call this breakdown voltage as Zener breakdown voltage as well. Okay, we will come to it. Before that we understood, if doping of the if the doping is increased, what will happen? Again we have to apply the high voltage, correct ada? Okay, so இப்போ வந்து we understood these many things. Okay, correct ada? Now let us just go for a very simple classification of forward and reverse bias. So in the forward bias forward bias and reverse bias, in the classification important da. Oh my god, sorry. Okay, so in the forward bias la வந்து in the depletion layer oda width வந்து reduces, also the potential barrier வந்து reduces. ஆனா reverse bias la in the depletion layer oda width வந்து it is going to increase, and in the potential barrier கூட it is going to increase when it comes to the reverse bias. Okay, and in the PN junction idla வந்து it will be providing a very small resistance. Okay, very small resistance da in the forward bias la. Okay, forward bias la வந்து small resistance da, ஆனா when it comes to reverse bias la வரும்போது high resistance da. Okay, it is nothing but the high resistance which is coming, and this is in the forward bias la in the current oda range வந்து milliampere, ஆனா வந்து reverse bias la வரும்போது it is coming as microampere. Okay, and definitely there will be a current flow due to majority charge carriers. Ana inga varumbodhu it is due to the minority charge carriers. Okay, and another one important point is regarding the our dynamic resistance. Okay, forward dynamic resistance, adu vandu adoda range vandu it will be coming around 10 ohm. Okay, the dynamic resistance vandu it will be coming around 10 ohm. This is nothing but the forward, the change in the forward potential divided by the forward current, and inga varumbodhu it will be coming around 10 to the power 6 ohm. In the dynamic resistance vandu it will be coming around 10 to the power 6 ohm. Okay, and in the knee voltage or cut-in voltage for germanium we have already discussed. Okay, for the germanium in the knee voltage வந்து 0.3 volt da, and silicon க்கு வந்து 0.7 volt da. And here we have the breakdown voltage, and when it comes to germanium it is coming as 25 volt. Okay, and for silicon it is coming around 35 volt. So whatever I have mentioned in the classification, each and every point vandu important da. So everyone has to note it down, and you guys have to go through each and every values. Yena compare பண்ணிருக்கிற questions vandu varadhukku chance irukku, adanaala da. Okay vada, everybody is fine with this? Yes or no? Please let me know. Everybody please let me know. Understood na? Give me a heart quickly. Give me a heart quickly. You can give me a heart. So quickly we can just go for some questions. Okay, so idhula vandu paakumbodhu In a band gap between valence band and conduction band in a material is 5 electron volt. Then the material is. Very simple question. Quicker you can give me the answer. இப்போ வந்து we have the band gap is given as 5 electron volt. அப்படினா அது வந்து semiconductor, good conductor, bad conductor, superconductor or insulator. Please give me an answer quicker. So we know that we will define conductor, insulator and what is semiconductor on the basis of energy gap. Correct? So in the case la varumbodhu very good, very good. We know இப்போ வந்து இந்த energy gap வந்து greater than, okay, இந்த energy gap வந்து greater than 3 electron volt na அது வந்து insulator தான். So இந்த case la answer வரது insulator. And next, an electron in the conduction band. An electron in the conduction band. Now you can just check on the options and you can give me the answer. Simple on a question tha, give me quicker, you can give me the answer. Very good Manju, insulator the answer. Now coming to this, an electron in the conduction band. How it will become A, Tarun? Electron na adukku charge negative. Adukku negative charge illa na adu electron illa. So how that will work? C. So conduction band na definitely we know, just think logically. Valence band la irukra electron ku extra energy kadacha mattum dana it will come to conduction band. Appadina which one will be having higher energy? Check it again. Okay, so inga valence band la irukra electron da idukku vandu top in the conduction band la poganumna adukku vandu extra energy irukanumla. Appadina in the C, or see how the C will matches with it, has lower energy than electron in the valence band. It is not possible. It should be high. Then D. Yes, then D. Okay, so now the answer is option D. Next, we can just go for. Okay, when the conductivity of a semiconductor is only due to breaking of covalent bond, the semiconductor is called only due to breaking of covalent bond. Understood? No worries. Make mistakes, study now, and exam ku vandu right we need to approach. That's it. So make mistakes multiple times. I don't have any issue. Ana vandu konjam kuda you should think. Okay, ena vandu simple concept da. Okay. Yes, so due to covalent na it is only this intrinsic. The n-type semiconductors are obtained when germanium is doped with n-type na 15th group element. So quicker you can give me the answer. Very good, very good. Quicker you can give me the answer. 15th group element. Yes. Come on. 15th group element. It is nothing but our arsenic, right? So option A is the answer. Now, suppose a pure crystal has 5 into 10 to the power 28 atoms per meter cube. Okay, so the concentration of silicon is given. It is doped by 1 parts per million concentration of pentavalent arsenate. Calculate the number of electrons and holes. And Ni is given as 1.5 into 10 to the power 16 per meter cube. This is also per meter cube. So, this is the given data. So, we have to use only one equation, Ni square, which is equal to Ne into Nh. Okay. So, now we are using only 1 parts per million of arsenic. Appadina, I can say that the number of arsenic vandu 5 into 10 to the power 28 oda 1 parts per million. Correct? So, இப்போ வந்து இவ்ளோ silicon இருக்கு. அதுக்காக I'm just using 1 parts per million of the arsenate. So I can just go for this will be coming as this is coming as 10 to the power 22 in the number of arsenic. Now we know that 1 arsenic will give 1 free electron. அப்படினா number of electrons வந்து 5 into 10 to the power 22 தான். Next வந்து what is the question? We got the number of electrons. Next வந்து holes தான். So either we know that here also we have Ni. Now you can just substitute those values and you can find Nh. So Nh will be Ni square divided by Ne. Can you do it now? Everybody? Do the calculation and give me the answer. Quick, you can do this. Ni square divided by Ne will be giving you Nh. Okay. So, இப்போ வந்து Ni na 1.5 into 10 to the power 16 divided by whole square into 5 into 10 to the power 22. Okay. So, now you can just do this. So now 2.25 divided by 5 will give you the answer. So it will be coming around 4.5 and so this is the approximate value of number of holes. Okay, done. Let us go for the next question. Are you guys ready? The conductivity of the intrinsic germanium, okay, at 300 Kelvin is, that is what we need to find. The conductivity that we need to find it. We know the equation mu into N into E. When Ni is 10 to the power 13 per centimeter and mu N and mu P in germanium, mu N and this is due to the negative charge, that is 3800, okay, and this one is coming as 1800 centimeter square. So this is how it is given. Now it is your turn to find it. Okay, so now these are the datas. We know the sigma value, which is coming as mu E plus mu H into N into E. So now you can substitute and you can find the conductivity. Quick, you can just, very good, very good, very good. Next question, you can go for it. Substitute and find it. Mu E is coming as 1800 and mu N is coming as 3800 and Ni is given as 10 to the power 13 and E value we already know 1.6 into 10 to the power minus 90. Can you do it? Quick, you can go for it. Everybody, quickly you can do it. A, B, C or D? Yes, very good, very good, very good, Dharan. So it is nothing but 0.0089 896 da idoda answer. So now we are going for the next question. On applying an electric field of intensity 10 volt per centimeter is a semiconductor at a certain temperature, the average drift velocity of free electron is measured to be 0 meter per second. Then the electron mobility is. So I think some correction is there in the question. So 770. So let us just make it as 70. Okay. Let us make it as 70. Now you can just do the question. So in the drift velocity வந்து 70 meter per second da and electric field வந்து 10 volt per centimeter da. You need the mobility. So finding mobility, we know the equation is nothing but Vd by E. Now you can substitute and you can just find the answer. Sorry Dharni. Okay. I was just read the first part only. Adanal I was thought like your name is Dharan. I forgot to read the last in I. Sorry. So now quick vantu you can do it. So idhula vantu mobility na drift velocity 70 meter per second da. Okay. And we need the answer in terms of centimeter. So 70 into 10 to the power 2 divided by, this is again in centimeter, so 10. Okay. So now 7000 divided by 10. So you will be getting 700 centimeter square. Got the answer? Got the answer? Yes or no? Quick in the madri questions ellame vandu rompa easy da. Correcta? Okay. So the answer vandu option B da. Okay. So now few more questions irukku. Right now I'm skipping it. We can do it on what is a Sunday class. So next one, the important thing is nothing but the IV characteristics da. So idhula vandu paakumbodhu when it is in forward biased, as we said, for germanium if it has reached 0.3, for silicon if it has reached 0.7 na adukappuram mattum da inda current flow irukum. Adukku munnadi irukkiradhu vandu inda minority charge carriers oda small current da. So when it has reached the knee voltage or let's say the potential barrier, so we can say that adukappuram there will be a current flow. Okay. When it comes to reverse current, and this will be, note panniko, idu vandu milliampere la da irukum. Okay, and the range important da. When it comes to the reverse direction, okay, when it has reached around 25 for germanium, 35 for silicon. So அந்த ரேஞ்சில் இருக்கும்போது அவ்வளோ ஹை வோல்டேஜ் இருக்கணும். ஸோ இங்கே வந்து இட் இஸ் 0.3 0.7 தான். ஆனால் ரிவர்ஸ் பயஸில் அந்த அளவுக்கு ஹை வோல்டேஜ் வரும்போது வாட் இஸ் ஹேப்பனிங் அட் சம் பாயிண்ட் இந்த டிப்ளீஷன் ரீஜியனில் the covalent bond will break and it will break down itself. So அந்த மொமெண்ட்டில் there will be a current flow. அது வந்து ரேப்பிடாக இருக்கும். ஸோ அந்த டைமில் இருக்கிற வோல்டேஜ் தான் பிரேக் டவுன் வோல்டேஜ். அண்ட் what is happening there will be a current flow. அதோட ரேஞ்ச் வந்து மைக்ரோ ஆம்பியர் கைஸ். the range வந்து மைக்ரோ ஆம்பியர் நோட் பண்ணிக்கோ. ஓகே, நெக்ஸ்ட் வந்து Zener வோல்டேஜ் தான். ஓகே, ஸோ இதுக்காக high voltage, okay, high voltage which means even this will happen under 5 volt, okay, highly doping irukano, okay, highly doped irukano. So on the moment illa what will happen at some point in the due to the high voltage there will be a breakdown due to covalent breaking off. Okay, covalent breaking off depletion layer. So on the moment as I mentioned the corresponding what to say in the voltage one, we will call it as breakdown voltage. We can also call it as the Zener voltage. Okay, ஏனா இந்த Zener diode வந்து, okay, Zener diode வந்து working under this breakdown region. Okay, it is working under breakdown region. And இதோட advantage என்னன்னா, let us say we are giving a fluctuating input. Okay, we have a fluctuating input. Okay, now there is a resistor which is connected in series. Now we have the Zener diode. Okay, so in the Zener diode one we can just represent like this. and adukapram we are giving the load over here, the device, whichever be the device we are giving, and inga vandu we are just checking the output. Okay, so idu vandu regulated ana output da we will be getting it. Yena, just listen. So in the Zener diode we have mentioned Zener diode vandu illana in the Zener voltage vandu it is nothing but the voltage at which the depletion layer will break itself. Okay, so in the Zener diode vandu work பண்றது அந்த பாயிண்ட்ல தான், இந்த reverse bias ல, okay, in the reverse bias ல breakdown region la da in the what is a Zener diode is working, and we can use it as a voltage regulator. Okay, voltage regulator. Adukkaga I have draw this figure. So inga vandu we are giving a fluctuating input. So ipo vandu due to this there will be a potential drop across RS. Correct? There will be a potential drop across RS, and idudha vandu namma Zener diode. Okay, idudha vandu namma Zener diode. Okay, so in the Zener diode advantage enna inga vandu whatever happens over here doesn't, I mean, we don't even need to, it is a DC source, a fluctuating DC source. Okay, so ipo vandu inga paakumbodhu it is connected parallel to it. So in the Zener diode la irukra, okay, in the Zener diode oda voltage da exact inga kadakkum. So if we are giving high voltage also, nothing will happen, and the rapid flow of current will happen, we have mentioned, right? Ana inge that is not going to happen. Okay, in the device ku vanda perfect in the Zener voltage, in the Zener diode oda voltage da kadakka pore. Okay, va? So the Zener diode as a voltage regulator na, we will connect this Zener diode parallel to the device. So what will happen in the device ku vandu proper idoda voltage da kadakka pore. Whatever it is fluctuating, deflecting, nothing matters. Okay, that is not a what is it, something which we need to discuss. Yena in the device ku vandu idudha vandu voltage. So we will be getting an output which is nothing but, as I mentioned, a regulated output we will get it over there. Okay, so idudha vandu we will be getting in terms of Zener diode as a what is it as a voltage regulator. So whenever we are increasing or decreasing the input voltage nalum, nothing will happen for the device, or the device will get exactly the voltage of Zener diode, and always it will be protected. Okay, vada, everybody understood? Okay, if it is in forward bias there is no issues, it will just work as a what to say our what to say simple diode, it will work. Okay, so next one I'm going to give you a question. Okay, here we have a resistor, and inga da namma Zener diode irukku. Okay, and inga vanda we have the device. Okay, so idhula vandu I mean we have few values. So and the resistance vandu 250 ohm da. Okay, and the resistance vandu this is nothing but 250 ohm. Okay, inga vandu we are giving 20 volt, inga vandu we are giving 15 volt, let us keep it as this is 1 kilo. Okay, so idu da vandu given diagram. Now what you guys have to find is the current through the Zener diode. Okay, the current through the Zener diode da you should find. Okay, so idhula vandu paakumbodhu we can see that there will be a current will be flowing. Let me just say this is the current which is passes through the resistance which is connected series, right? And it will be splitted as 2. Correct? It will be splitted as 2. One will be passes through the Zener diode, another one is passes through the load. So now I am making a relation using our current electricity Kirchhoff law. Okay, the junction rule. IS will be equal to IZ plus IL. So either the one relation we made it from here. Now the thing is like you can simply find IL. what is going to be IL? The potential across that load resistance divided by the resistance. So அப்படினா இங்க வந்து பாக்கும்போது we know the potential is same as the Zener diode. We already discussed about that. ஏனா அந்த டிவைஸ்க்கு அந்த லோடுக்கு வந்து கரெக்ட்டா whatever be the potential of this one, we will be getting that. So அப்படினா 15 volt தான் அது and resistance வந்து 1000. Okay vada. So now you got the current flowing through the what to say, the load. Okay, adu vandu it is nothing but the 15 milliampere. Next vandu I can also check this IS as well. Yena I'm using the loop rule. Okay, while I'm checking the loop rule now, I can see that there is a 20 volt, here it is a 15 volt. So you can see that 20 volt minus 15 volt divided by the resistance which is coming as 250. So we will be getting 5 by 250. So while we are doing this, we will be getting this value. So it will be coming around 20 milliampere. Correct? 20 milliampere da in the current through the series resistance which is coming. Appadina next vandu use this in this equation, IS which is equal to IZ plus IL. Appadina IS minus IL will be coming as IZ. IS now we got it as 20 milliampere minus 15 milliampere, which will be giving you 5 milliampere. So this is one of the question we can expect from the Zener diode. Everybody understood? Now give me a fire in the chat box. Quicker you can give me. Quicker you can give me a fire quickly if you understood now in the question, or if it is needed to be discussed again now, please let me know, I will help you. Everybody. Done? Okay. So next one is another one, that is Avalanche breakdown. Okay. So idhila vandu it is something like the Zener diode Zener breakdown we have mentioned. So idhila vandu lightly doped da. Okay, lightly doped da. This is also happening in the reverse biased condition. Okay. And also inga vandu paakumbodhu in the minority charge carriers. Okay, in the minority charge carriers will accelerate in the depletion region. Okay, so on the depletion layer, the acceleration nadakumbodhu, what will happen? There will be collisions will happen. Okay, so in the depletion region la, what is exactly happening in the minority charge carriers vanda and the depletion layer la, they will accelerate. Due to that, there will be some collisions will happen, and this collisions will leads to knocking out of valence electrons. Knocking out of electrons will happen. Again, what will happen? The breaking of covalent bond. Breaking of covalent bond. So again, there will be electron hole pairs will be formed. Okay. So again, there will be the things which we have mentioned, like the again collision, again the number of charge carriers will increase, and sudden reverse current will also happen. Okay, so in here we can say number of charge carriers will increase, and due to that there will be a reverse current, and there is a possibility of permanent damage of this diode in the avalanche breakdown. Okay, so very simple da in avalanche breakdown la it is happening in the reverse biased condition, lightly the doped irukku. Next vandu nothing but the minority charge carriers. Okay, minority charge carriers will accelerate in the depletion region. It will collide and it will knock out the electron. Again, electron hole pair formed. Again collision. Again this thing will repeat, and again the covalent bond will break. This process will repeat. Number of charge carriers increases. Due to that, again a huge current will be there. Ana vandu idu vandu high voltage la da it's happening. High voltage na like it will happen more than, if the voltage is more than 6 volt, okay, then only in the avalanche breakdown will happen. Purinjadada everybody? Yes or no? Yes or no? Now we need to study some devices as well. Okay, ready ada everybody? We have to study some devices. Ready, ready, ready? Ready now? Everybody should tell me. Yes. So now let us quickly go for the devices. So in this first one, the LED da. So few things only you need to study. In the LED na, in the light emitting diode is actually work in the forward biased condition. Okay, there is nothing but we will be call it as, we will mention it as this is happening in the forward biased condition and the energy released in the form of light. Okay, and when it comes to germanium and silicon, they will release the light in the infrared region. Okay, so basically we should know it is a heavily doped PN junction and it is happening under the forward biased condition. And when we are talking about the the electron hole this motion, during this process some energy will be released and the energy is in the form of light. So depending upon which are the semiconductors we have used for making this PN type, so depending upon that it will release some colors. Okay, so when it comes to germanium and silicon, it will be in the infrared region. Okay, and this is the LED advantages that you can just go through it. Okay, understood? So now this is heavily doped under forward biased condition and it will produce the light. Okay, at the junction boundary on either side of the junction, excess minority charge areas were there which recombined with majority charge areas near the junction. On recombination, energy is released in the form of photons and the photon order wavelength depend panni there will be some different colors will be formed, and that is how we will be getting the light, yellow color, green color, red color LEDs and all. Next one, the application, another one is photodiode. Photodiode is also working under reverse biased. LED mattunda in the forward bias la irukku. Next whatever we are studying, that is one the reverse bias la da. Okay, idu one the reverse bias la da it is happening, and when we are giving some light, okay, when we are giving some light to the PN junction. Okay, when we are giving some light, what is happening? There will be the light with energy greater than the energy gap. In the valence band electrons, it will get some energy, and there will be again energy gap of this and then electron greater the energy gap of the semiconductor. Then the electron hole pairs are generated due to the absorption of photons. So when we are representing LED na, this is how we will represent in case of LED. Okay, so this is how the the light will emit in case of LED. When it comes to photon na, this is how we will represent. The light should fall on it, and on the light oda energy vanda it should be greater than. Okay, at this voltage what will happen to the diode, ma'am? Which voltage da you are talking about? Which case, Darun? Okay, so ipa vanda application of PN junction in photodiode only you are asking. Okay, so photodiode la we will be giving some light, and the light energy used panni there will be electron hole pair will be formed, and it is due to the photon absorption, and the process in the photodiode work pandra. So which is actually used to to understand, or let's say to get the intensity of light and all, we can just check it in the video camera and all we are using. And also one thing is like it will break down and the diode will be get damaged permanently. There is a possibility of permanent damage. Okay, So இப்போ வந்து what we were discussing, yeah, photodiode. So we know that when you are going to mall and some restaurants now, we know that I mean they will understand the presence of hand and the water will come in the pipe, right? So அது வந்து photodiode தான் அங்க வந்து யூஸ் பண்ணிட்டு இருக்கு. Okay, when we are just going, okay, when we are just அந்த sense பண்றது வந்து நம்ம hands தான். அந்த hands வரும்போது அது வந்து it is obstructing the light. Okay, so then the water is coming. That is the logic behind it. So photodiode la vandu I mean you have to understand, important you should understand idu vandu happening in reverse bias. Okay, and also idukku vandu light thevaiya irukku, intensity of light depending upon this will work. Okay, next one the solar cell da. In the solar cell la main thing is like we are not using any bias, forward bias, reverse bias, nothing. Okay, we are actually producing the EMF. So அதுக்காக we will take a PN junction. So அதுல வந்து any of this P or N should be thin. Okay, அதுதான் வந்து first thing you should notice. Solar cell we are not giving any biasing, and second thing is like any of the P or N supposed to be thin. Okay, and it is works on the same principle as I mentioned, but the thing is like photodiode the same thing da, ஆனா வந்து இதுல external bias is not applied. The junction area is kept much larger for solar radiation to be incident because we are interested in more power. Okay, generation of EMF by solar cell when light falls on it, it is due to the three basic process: generation, separation and collection. So idha vandu the three things we should study. LED, Zener diode is already done, LED, photodiode and solar cell. So idhula vandu we should say about this LED is working at a forward bias, and when it comes to the photodiode it is works on the reverse bias, and for this one it is in the solar cell la vandu we are not giving any external bias. Okay, and also idhula vandu light will be emitted, idu vandu light should absorb, in the solar cell la kuda light vandu absorb aga pore. Okay, so idu da vandu major ana things which we should know. Okay, so next vandu rectifier da. Ready ada? Rectifier akapram we have logic gates, adukapram we are going to finish this lecture. Quickly we can finish it. Okay, so in the rectifier la simple as onnena we know that in the diode ku vandu same direction la irukra current mattum da it can passes through it, which means idu vandu unidirectional, and the property that we are using for I mean as a rectifier. So rectifier na it is nothing but we need to convert AC to DC. Adukagada we are using the rectifiers. So idhula vanda half wave rectifier irukku, full wave rectifier irukku. Half wave rectifier la we are giving the AC input. Okay, transformer irukku, and the transformer la we know in the side vandu positive ah irukum, in the side vandu negative ah irukum. So when it comes to an AC source in the first half cycles, okay, so இதுதான் வந்து நம்ம AC source. Okay, இதுதான் வந்து நம்ம varying AC source. So when I'm talking about the first half, which means this much only. Okay, when it comes to here, no worries. In the side la vandu idu vandu forward bias da, positive cycle da, forward bias da, it will give you an output. Next vandu in the negative cycle da, when it is coming to the negative cycle, what is exactly happening? This is the negative cycle, so this will become in reverse bias. Okay, inga vandu negative aga pore, so it will be reverse bias. Reverse bias la we know it cannot it cannot allow the signal to passes through it. So adanal in the negative cycle la we won't be getting any output. Again the same thing, idu vandu positive da, forward bias, it will give you an output. Again negative da, what will happen? Again it is in the reverse bias, so nothing will happen. So appadina we can say that in the half wave rectifier la positive cycles ku vandu we will be getting the output. Negative cycles ku vandu we are not going to get anything. Appadina I can just go for the graph. Okay, so இதுதான் வந்து நம்ம input, ஆனா output வந்து we will be get it like this only for the positive half. Okay, so இதுல இருக்கிற positive half, இதுல இருக்கிற positive half. So இந்த மாதிரி தான் இந்த output வரும், and almost 40.6% தான் இதோட efficiency of the half wave rectifier வந்து 40.6% தான். And அதுக்கப்புறம் you should also know one thing. So இதுல வந்து what is the frequency of the input? Okay, the input order frequency and output order frequency வந்து same ஆக போகுது. okay, input and output வந்து same ஆக போகுது. Next வந்து full wave rectifier தான். Full wave rectifierல we are using a center tapped transformer. ஏனா we need to flip the what is it once we got the positive half cycle na and the other endல வந்து we need to make it 180 degree flip. So அதுக்காக தான் we are using a center tapped transformer. So இதுல வந்து same process தான் ஆனா 2 diodes இருக்கு. Okay, we have 2 diodes. So இதுல வந்து first half cycle வரும்போது what will happen? இது வந்து forward bias இல்ல, இது வந்து reverse bias இல்ல. ஏனா first half cycle ல this will be having the positive cycle. இது center tap தானால இங்க வந்து there will be a 180 degree flip. So இப்போ வந்து இது வந்து reverse bias ல தான். ஆனா this will give a output. Next cycle la varumbodhu, okay, next cycle la varumbodhu what exactly happening? Inga vandu negative da paravalla, idu vandu reverse la no output, aana inga vandu idoda 180 degree flip da. Okay, so ipo vandu idu vandu forward bias la this will give you the output. So அந்த மாதிரி positive half cycle வரும்போது it will give in the D1 வந்து output, I mean D1 ல இருந்து we will be getting the output. ஆனா when it comes to the negative half cycle we will be getting the output from D2. Okay vada, everybody understood? Yes or no? Please let me know in the chat box, everybody. Yes or no? Everybody tell me. Okay, so idhula vanda percentage of efficiency vanda 81.2% efficiency, and idhula vanda frequency na input frequency oda double the output frequency. Okay, 2 times of input frequency will be coming as the frequency of output, which means input frequency 50 na output vanda it will be coming as the 2 times, so it will become 100 hertz. புரிஞ்சுதாடா? Everybody understood? Yes or no? Yes or no? Okay. Okay. So next one we have the logic gates da. Okay. So logic gates one let us continue now, because anyway I need a break, just 2 minutes only. I just wanted to refill my water and I want to come. Okay, can we continue? Okay, anyway let me just take a small break. Okay, I'll just come in 2 minutes. Let us continue after that. We can just wind up with after finishing logic gates. Okay, va? let's continue. Are you guys ready? So right now the thing is like we are going for the logic gates. So logic gate is nothing but a digital circuit that follows a logical relationship. Okay. So for that we have OR, AND as well as NOT. Okay. And the universal gates irukku adu vandu yes, what are the universal gates? அது வந்து NOR or NAND. Okay, so அதுதான் வந்து universal gates. So அதிலிருந்து we can just make any of the other one. So logic gatesல வந்து we use Boolean algebra, so which we need to to represent. Okay, in the இப்போ வந்து we are giving this input. Okay, அதோட output என்ன, அது அந்த representationக்காக we are using this. And first வந்து OR gate தான். So இந்த OR gateல it is very simple. We are giving an output. Okay, so we are giving A, B. Okay, so idhula vantu what is happening, we will be getting, let us if I'm giving 1, B also 1 na, adoda output vandu 1 plus 1. Okay, so we will be get it as 1. Okay, next one I'm giving 0 and 1, again we will add it. Okay, appo 0 plus 1 na, again 1, then 1 0, again it will 1, again 0 0 0 plus 0 vanda it will be coming as 0. So which means an OR gate represents, or the output will be coming as A plus B. Okay, adudha vanda OR gate. Next vanda nothing but our AND gate. Okay, AND gate na, this is how we will represent. Okay, so ippidida we will be giving the input. Okay, so now let us say A, B is here and idudha vanda output. So 0 da we are giving, here also 0, appadina idu vanda 0. Next vanda 1 0, 1 into 0, again 0, 0 and 1, 0 into 1 will be coming as 0, 1 into 1, that is 1, which means A into B da nothing but our AND gate. Purinjidada? If you understood, give me a heart in the chat box. Everybody quick vandu you can give me. Okay, so ipo vandu we found the OR gate, adu vandu nothing but A plus B. AND gate na nothing but A into B. Okay, so AND gate oda output vandu A into B da. Next vandu we should know NOT gate. Okay, so NOT gate na very simple. Okay, if I'm giving 1 na, I will be getting 0. If I'm giving 0 na, I will be getting 1. Which means if this is A I'm giving na, in the our output vanda it is coming as A bar. Oh my god, I still remember vectors it seems. Okay, so Y is equal to A bar da in the NOT gate. Next one in the combination da, as I mentioned, first one the NAND gate. Okay, so NAND gate la very simple. So this is what our AND gate, adula vandu we are going to add this NOT as well. So ipo vandu we know that idudha vandu A, idudha vandu B. Appadina we will be getting A dot B bar. Okay vada, so when it comes to NAND gate, we will be getting A dot B bar. And according to De Morgan's theorem, we can also write this is coming as A bar plus B bar. Which means if you are giving A, B, then A bar, B bar, then A bar plus B bar. Which means you are giving 0, 0, then idu vandu 1, 1. So you will be getting 1 plus 1, again 1. Next vandu you are giving 0, 1. So appadina idu vandu 1, idu vandu 0. A plus B paakumbodhu it will be coming as 1 plus 1, it will be coming as 1. So like this way we can just go for the, no, as EVS is over. No, idu vandu NEET kaga irukra preparation. Okay, so ipo vandu idudha vandu namma NAND gate. Next vandu nothing but our NOR gate. NOR gate nalum simple da. Okay, NOR gate nalum simple da. So we will add a NOR. Okay, so idu vandu A, idu vandu B. Okay, so appadina we can say that A plus B bar in the NOR gate, A plus B the whole bar, which will be coming as A bar into B bar. So exactly the similar way how we have done previously, A, B, A bar, B bar, A bar, A bar into B bar. So now A I'm giving 0, B I'm giving 0, A bar na 1, B bar na 1, and multiply பண்ணும்போது I will be getting 1. So இப்போ வந்து I'm giving 1, 0, அப்படினா இது வந்து 0, இது வந்து 1, and while I'm adding this, multiplying this, I will be again getting 0. So like this way, we can just go for the NOR gate as well. So usually in the universal gates na, usually we will say in the NOR and NAND gate da idoda universal gates varadu. Okay vada? Okay va? So next we have XOR and XNOR gate. Okay, so you should have an understanding. Okay, so idhula it is very simple. XOR சொல்லும்போது very simple. If you are giving, okay, இப்போ உங்களோட ரிசல்ட்ல 1 இருந்துருச்சுனா, okay, ஏதாச்சும் 1, I mean 0 or 1 இருந்துருச்சுனா, அதுல you will be getting it as 1. Okay, at least 1 should be I mean anyone should be, I mean if you are giving A and B input na, so adula edachu 1 irukkanum, then you will be getting the input XOR gate attains the state of 1 if one and only one input attains the state 1. Okay va? And XNOR opposite da, if you are getting 1 in XOR na, adukku opposite da what is XNOR. So idu da we need to study in the logic gate. So next let us do 1 or 2 questions. Adikapram we can just go for it. So how many NAND gates are required to form AND gate? How many NAND? Because we can just use AND gates and we can make, we can use NAND gate and we can make the AND gate. Okay, the AND gate from NAND gate. Simple da. Can you just give me the answer? Can you give me the answer? Try it. Just think about it. We need to get AND from this universal gate NAND. Simple da. Let us say, idu da namma NAND gate. So adikapram idilirundha we can just go for the another one. Okay, so this will be giving you the AND gate, which means we have at least 2 NAND gate will give you the AND. Okay, so idu da A, idu da B, and here you will be getting Y dash. Okay, here you will be getting Y. So ipo I'm just giving A, B, and Y dash na, it will be coming as A dot B bar. Correcta? Okay, and then Y will be coming as, the inputs are going to be same. Correcta? So now you can just go for substituting this using De Morgan's theorem. Can you just give me the answer? Just give me the answer. So idhila what is going to be Y dash? Adukapram in the Y dash the same A and B is coming for this one. Let us say I'm just marking it as A dash and B dash. Okay, you will be getting the same one. Okay, so while doing this you will be get to know idoda answer it is nothing but our the product which we will be getting as AND. So next in the given combination of gates, if the logic gates of input A, B, C are follows. First case A, B, C 0 da. Second case A, B is equal to 1 and C is equal to 0. So ipo if you are giving A and B as 0, okay, so 0 0 na idu OR gate da, so you will be get it as 0. So inga the product 0 da, and C is also 0. Idu NAND gate da, 0 0 into 0 into 0 will be get it as 0, and taking the note of it we will be getting 1. Okay, so first order answer 1 da. Next case what is happening? We are giving 1 1 and 0. So in the case 1 plus 1 na, it is again coming as 1. Inga 0 da. So 1 into 0 0 da, and adoda note 1 da. So answer will be coming as 1 1. Okay, so more problems we have to do for the logic gates ஏன்னா tricky questions எல்லாமே வந்து இதில் தான் we are expecting. So அதனால மறக்காம இந்த Sunday class வந்து attend பண்ணிக்கோ. 10 AM onwards we are going to practice the questions till you people become bored. அந்த time வரைக்கும் we will do the questions. So in the sessions விட you have some concept clarity ஆனா questions practice பண்ணலைன்னா you are not going to get a single mark. So அதனால தான் I'm telling you everyone should focus on this, everyone should study, then only you will be getting it. Okay va? Everybody is ready? Yes or no? Are you guys ready for the Sunday session? Okay, so let us meet on Sunday. Till that, bye bye.